Hello and welcome back to the channel. Long time to see. Some time have passed from our last video. I was busy with the wedding, busy with lots of married man stuff, also work, but finally I had time to prepare a little bit longer course for you. What we'll be working on is Zelda-like game, uh, but not precisely recreation of Zelda. One important thing, we will be using Ninja Adventure asset pack, which is really rich and wonderful. You can find it on itch.io, and it is like definitely enough to create a game. There are also exemplary projects for Godot 4.0, so you can download those and play around and maybe find inspiration for you. We are using the latest version of Godot 4.3, and this is due to the fact that we will be using tilemap layers instead of tilemap, which is like a new node for Godot 4.4. So the tilemap is getting deprecated in the upcoming versions of Godot, something to bear in mind. Okay, so I will create new project. I'll find a suitable place for it. I will create new folder, call this Zelda course. It's the current folder. Don't need this. This is Zelda course. The renderer is forward, even though it does not matter. The version control metadata is Git. You'll find the code link in the description below. It is available on my GitHub as always. So let's create an edit. And for this intro, I'm gonna do one more thing because I don't want to get things screwed up. I will quit the project list, and I found it a very good practice to set proper tags. As you can see here, I have YouTube material preparation where I prepared the code and our solution before. Now, right now, I will add YouTube actual recording, since this is what I am recording, to this course. It is really cool that you can add those tags now. Very helpful. So let's open this app. And there are two more things I would like to do. One is go to project settings. And as you can see, we will be working with pixel art. So by default, I would like to set our filters here. So we need to find, if this is rendering textures, and default texture filter should be, it is linear, which is good. The nearest basically you use with the vector art, it makes the pixel art blurry. So make sure that you have linear chosen here. And the second thing that I would like to use is to actually bring the asset that we need, the asset pack. So let's just create new folder here, call this assets, grab everything that we need and drop it here. Let's import that and make sure that we bring this into the folder. It will pop an error, at least in 4.3. Don't worry about this. And then we can move also this, right? And there we have it. So this is everything that we needed. We'll be working with tile sets here, right? Yeah, I believe this is all that we need for the setup. So in the next part, we will be working with the basic tile set setup, and I will try to explain to you how auto tiling works. See you in the next section. Okay, so now to start working on our map, let's start by creating the main scene, which I tend to always do. So create new folder called scenes, and I will create root node, which is going to be an empty node called main, and press Ctrl S to save it. And I will add another child node, also empty, and I will call this tile layers. And here is the one of the biggest differences between earlier versions of Godot. When I will search for tile, you can see that tile map is being deprecated, and we are supposed to use tile map layer. So let's do that. I'll create let's call this ground tile layers, and we can start working on our first layer. This will of course require a tile set, so let's create new tile set, switch to it here at the bottom, and we need to bring the proper tile set. Let's see, I believe that the tile set floor is what that interests us, as it will allow us to start working on the tiles that we would like to present in the level. So here I can zoom with my mouse wheel, and you can see that we have different types of ground. I will focus mainly on this one, which is like the light grass, let's call it. And of course, to work with that, I can just go to tile map, select any, and start drawing, right? And I can draw the rectangles, or just I can draw like a singular tile, and I can select the rectangle and use the right mouse button to clear it all off. The one thing that I would like to achieve, and this actually explains why the tile sets are arranged in the way they are, is to actually have autotiling, which is a set of rules that we can specify to make use of the fact that we would like our grass to be on the edges of our area and the dirt patch to be inside. Okay, and to do that, we need to create something called the terrain. Okay, so I can go to my tile map layer, to my tile set, to terrain sets right here, and I would like to create a new terrain set. And these are identified by the ID, where ID -1 is like no terrain. And here we have different modes that I would like to discuss. Let's start by creating first terrain first, and I will call this light grass. And I can specify a color for it, like light green. Okay, so this is just the configuration of the terrain set. To actually use it and add given tiles to a tile set, I have to go to tile set, and then paint properties, and from the property editor I will select terrain set 0, so this is the one, and then from it I will select the terrain that I'm interested in, which is light grass. Okay, and now as you can see, I can add the tiles to given terrain set. Okay, if I will go now to tile map and terrains, nothing is added here, right? Nothing is being drawn as I am drawing, right? So if I start adding stuff to it, by clicking on it and go back to light grass, you can see still nothing is added here. To add a tile to a tile set, when defining the auto tiling rules, you have to select that middle square, okay? Actually, let me start by using match sides, okay? And I will add this and this, still nothing here. But if I select the middle square here and here, oops, sorry. Why does it show only that? Oh no, we have both here, right? And as you can see, we have two options here to draw, like connected mode, which is for drawing the areas, and then the path mode, which is used to create the paths. And as you can see, the placement of those is rather random, right? There's no sense in how they're being placed. But here I can start defining some rules. So let's start with the vertical one. If I will say continue drawing that tile whenever the upper tile and bottom tile is the same, and go to tiles now and select path and start going vertically, you can see they're now connected, right? And the same goes for this one because there's no other rule for that. Going back now, if I remove those rules and start drawing vertically, oops, you can see this is all messed up because there's no rule for how the tiles should connect in given direction. Okay, and as you saw, probably, I do not need to specify the rule for the horizontal one. Now let's remove this. Right, it's gonna work out of the box. And this is because, well, the rule set for the vertical is defined and the other direction is of course horizontal. So basically the rules specified for the vertical tiles prevent it from being drawn when I'm drawing a horizontal line. Okay. And of course, if I were to switch those, now when drawing vertical line, right, you can see we have the horizontal tile selected because that's how I specify the rule set, right? So if I'm going from top to bottom, always draw this one. And if I'm going from left to right, right, always draw the tile with the dirt patch being vertical. Okay, so let's set this up correctly. Right, so this is what can we achieve when it comes to matching the sides. Okay, so let's move real quick to the match corners mode right now. So the match corners can be used to draw up a set of dirt patch with a border around it. I will remove that for now, and I will add this this tile to our terrain, and I will select all of the corners for it. And then if I go to continuous mode in the terrain and start drawing, I will get a dirt patch. But of course, I would like to have it respect the corners. So it can be done by selecting the corners that should match together. This is pretty simple. I'm just avoiding the border grass here. So definitely this, when you hit the edge, this tile should magnet and connect to this one. Of course, this corner should connect to this one. This tile should connect also to the middle one. This corner here, here, and here. And of course, we need to add those tiles into our set by clicking on the middle rectangle here. And with this done, I can go back to my terrain, select the continuous mode, and now, as you can see, it almost perfectly have the border. So let's check what are we missing here. Let's see. This is connected, this is connected. Oh no, I can see it working. Maybe it was just some kind of problem with, I know, time map. And you can see I can create a perfect rectangle, which is really, really good. But then there are problems, right? When the two rectangles that I have drawn are connecting, right? Because matching sides is not enough. Matching corners, sorry, is not enough, because we're here not only matching a corner, but we're also matching a side, right? So we need to improve the definition of our auto tiling, right? This is the corner we're matching, which is correct, but here it doesn't match the side. So now I can just select match corners and side as a mode, and this will allow me to improve our definition. So again, we need to fill this out, right? And we know that for that side, we should match with the center tile. That goes for all of our tiles. Again, this is pretty much filling out the definition where we have the dirt, and I can remove that for now. Okay, so we filled the whole square. Now, if I erase all of that with a right click and start drawing, see that the definition will allow us to pretty much perfectly draw the tile. Yet still we have some issues when matching the sides, so we need to extend our definition even farther. Let's go to Tileset, and now if I like to draw here, you can see it should match with a different tile, the one that has a piece of grass here, and otherwise it would have dirt. So let's check where we have something like this. So I believe that should be that tile, right? It should match perfectly into that place. So we need to add this. Okay, we'll add it to Tileset and say basically use it when matching dirt here, 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 and here. So with that added, going back to Tileset, and I would like to, you can see it being used here, and I would like to place it here. It's getting filled correctly. Okay, so to match those strange like corners, we need to set the proper definition for that part. And as you can imagine, it is going to be pretty much the same, just avoiding the grass, matching the dirt. Okay, going back to tile map. I'll start drawing now. I can see that the corners are being filled correctly, right? But there's again lack of definition for other cases. For example, here, right? How to match a case where we have grass at the top and then the dirt in the bottom. So again, extending it further is pretty much simple. Just knowing that we would like to have our dirt in the middle. So we are just checking everything and avoiding the grass. So it goes like this, this, oops, not that, this, and not that, this, and then here and here, here and here, here, and I believe here, here, and here, here, here. This is, I believe this is all good. Oh, we have a dirt here and here and here. And this looks correctly to me. So again, going back to the tile map. Now, if I try to draw, it is almost good because still lack of definition. Basically, we have to define the whole tile set. So again, avoiding the grass, just painting along the dirt lines, just like this, just like that. This is dirt, this all is dirt, and this is dirt. You can see that, for example, here we have a piece of grass, so I'm not going to include this, and this. And I believe we're almost good. We also need to include this. And for that, also moving along the grass lines. Okay, and that's pretty much almost all. So now, as you can see, I can try and do it almost perfectly. One problem is here, you can see with the horizontal lines, the path does not look too good, right? And this is somehow blurry, so the default filter should be nearest instead of linear. My bad. So we need to add the definition for horizontal line and single patch. So that pattern should be good for our auto tiling definition. Perfect. Should also allow us to like draw a path. Right, so I can just draw a path for our player. Okay, there's another thing I would like to discuss in that part, which is how to use probability for tileset. So as you can see, we not only have this definition of our dirt path, which is like completely covered by the dirt, but also this. And if I were to include this and give it the same tiling definition and start drawing, oops, this one, right? It creates the dirt patch inside with the use of free tilesets that I set to have the very same sides and corners. The problem is I don't want them to occur as often as this one. So what I can do is go to paint and choose probability, set the probability to 0.05, and say that this tileset and this tileset should occur less often than this one. They have the same auto-tiling definition, but I want them to occur more rarely. If I grab this now and paint over it, you can see it still does connect pretty much perfectly, but these tiles occur less often. Okay, so this would be the pattern used for the auto tiling definition for top-down game when you have complete tile set. Again, just going against the dirt lines, the corners are matching, right? The sides are also matching, right? So if this is the corner and then we go horizontally, this tile set, if this is a side, sorry, and this is a matching side, and we go along that line, we should use that tile. Okay, I believe this is it. In the next episode, we will handle the water tile set, as it is a little bit different and we'll also need it. So I'll see you there. Okay, we'll add it to tile set and say basically use it when matching dirt here, 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 and here. So with that added, going back to tile set, and I would like to you can see it being used here, and I would like to place it here. It's getting filled correctly. Okay, so to match those strange like corners, we need to set the proper definition for that part. And as you can imagine, it is going to be pretty much the same, just avoiding the grass, matching the dirt. Okay, going back to tile map. I'll start drawing now. I can see that the corners are being filled correctly, right? But there's again lack of definition for other cases. For example, here, right? How to match a case where we have grass at the top and then the dirt in the bottom. So again, extending it further is pretty much simple. Just knowing that we would like to have our dirt in the middle. So we are just checking everything and avoiding the grass. So it goes like this, this, oops, not that, this, and not that, this, and then here and here, here and here, here, and I believe here, here, and here, here, here. This is, I believe this is all good. Oh, we have a dirt here and here and here. And this looks correctly to me. So again, going back to the tile map. Now, if I try to draw, it is almost good because still lack of definition. Basically, we have to define the whole tile set. So again, avoiding the grass, just painting along the dirt lines, just like this, just like that. This is dirt, this all is dirt, and this is dirt. You can see that, for example, here we have a piece of grass, so I'm not going to include this, and this. And I believe we're almost good. We also need to include this. And for that, also moving along the grass lines. Okay, and that's pretty much almost all. So now, as you can see, I can try and do it almost perfectly. One problem is here you can see with the horizontal lines, the path does not look too good, right? And this is somehow blurry, so the default filter should be nearest instead of linear. My bad. So we need to add the definition for horizontal line and single patch. So that pattern should be good for our auto tiling definition. Perfect. Should also allow us to like draw a path. Right, so I can just draw a path for our player. Okay, there's another thing I would like to discuss in that part, which is how to use probability for tileset. So as you can see, we not only have this definition of our dirt path, which is like completely covered by the dirt, but also this. And if I were to include this and give it the same tiling definition and start drawing, oops, this one, right? It creates the dirt patch inside with the use of free tilesets that I set to have the very same sides and corners. The problem is I don't want them to occur as often as this one. So what I can do is go to paint and choose probability, set the probability to 0.05 and say that this tileset and this tileset should occur less often than this one. They have the same auto tiling definition, but I want them to occur more rarely. If I grab this now and paint over it, you can see it still does connect pretty much perfectly, but these tiles occur less often. Okay, so this would be the pattern used for the auto tiling definition for top-down game when you have complete tileset. Again, just going against the dirt lines, the corners are matching, right? The sides are also matching, right? So if this is the corner and then we go horizontally, this tileset, if this is a side, sorry, and this is a matching side, and we go along that line, we should use that tile. Okay, I believe this is it. In the next episode, we will handle the water tileset, as it is a little bit different and we'll also need it. So I'll see you there. Okay, so in this section, we'll work on adding water to our tileset. So what we need first is go to tileset and add another tile atlas. This is going to be tileset water. Let's drop it here, and as you can see, we have a bridge here, a little bit of different sets of water, a little bit of decoration, a boat, stuff like that. So here is the part that matches our light grass. Okay, so I would go to our tileset configuration and I will add water, light grass, and let's make it blue. This is nice. And we have to think, how should we add the auto tiling here? So let's go to paint, terrains, water, light grass. So it's gonna be similar for that part to how we added the dirt patches. So these are the bordering tiles. Let's select all of those and let's add them to our set. Okay, so when these side match, right, when we're going horizontally and this is the corner side, we should use that. Same is matching here, and this, and this connects to this, and this connects to this. Now for the corners, if this is a definition of upper left corner, extending that to the middle, we should use this. Same goes here, same goes here. So imagine these two being like connected magnets, right? And then of course, when extending to this side part, like being a border, we use this. Same here, and then for this corner, we use this, this, and this, this, and this, right? That's gonna be almost good, because if now I will try to create a water patch, right? You can see, yeah, we lack the definition for the corners of grass. So the same issue we had there. So I can just go here and then paint the water and take care of the corners. Okay, and now if I go to water-like grass and start painting, right, I can see that this makes sense. And I believe this amount of the definition for the water is enough, right? Because otherwise it's gonna connect pretty much perfectly to our grass. One thing that I would like to do though is add a little bit of decoration. So these are going to be decorative tiles, which are to replace this center tile. So let's paint all over them and changing the probability, sorry, to, let's say 0.1. Okay, and also maybe just for fancies, I could add this one. So let's add it to terrain first. Yes, and then for the probability, I will do even lower, 0.05. Okay, and let's try drawing our water right now. As you can see, it looks more differentiated, more complex, just nicer. Okay, so we have the water set up. Now we can talk about, since we have a water, we have a dirt, maybe we could build a bridge, and we'll do that in the next section. Okay, let's try adding a bridge now that we might use for our tile set. This is again going to be from the tile set water, and here we have an example of a bridge. So add element, this is going to be bridge. I will find a orange-like color to match the color of the tile sets. And here in the paint, going to terrains, bridge, let's just start painting. Again, the same set of rules applies, matching corner and sides. This is a very simple pattern. You just draw a square in the middle. Okay. We could do also like this and this. since we're here. And also adding the alternative tiles. So this will be looking kind of broken, which is nice. This will replace the middle tile here, but with lower probability. So going to probability, 0.5, 0.5. Pretty simple. This should give us a bridge. So let's try this out. Okay, the problem is that it will add this to like a grass, as you can see. I think that's not really what we want, right? We would like to have this above. So what we can do is treat this as a decoration. So I will add a tile node and create another tile map layer. Call this decoration tile map layer. And what I will do, because the bridge is defined in this tile set, I will reuse that tile set, but by converting it into reusable resource. So save as. I'll create new folder, tile sets. Call this tile set. And then I can quick load here my tile set, select the bridge, and now we have a bridge, right? If we go here, this is how it looks like, right? So this, we'll use this to create ground tile layers, and for decorations or things that are overlapping, right? We will use another tile map layer, tile map layer. Perfect. Moving on, what I would like to add when it comes to our tile maps is the ridge and snow ridge and the stairs. So we will handle this in the next section. Okay, now building the how do you say, height, so giving the some kind of height to our tile map, we could use a ridge, which should be defined in tileset relief. So let's go to our tileset. I believe this is the one. Yeah, so as you can see here, we can create some kind of height information. Okay, so this is like going up, or at least we could make it look like it is. So again, going to our ground tile layer, I will add another element, and this is going to be called snow ridge. I will make this probably kind of grayish. Okay, I can go back to tile set, select paint, terrains, snow ridge, and I can start simply with using those. All right, and this again goes into creating this square in the middle. Okay, and if I go to a tile map, select snow ridge, right, I can just create a ridge somewhere here. Okay, so this is like extruding up, and I can make it a little bit better because I can also add this, and let's try and set up the correct behavior for that, starting with the square in the middle. Okay, and then going to a tile map. Right, now it's unfortunately all messed up. Right, but what I will do is instead create another terrain, and I will call this snow ridge wall, and let's make it darker gray, almost black. Select it here and paint it here. Okay, and now going to a tile map, I have the wall, and then I have the snow ridge. Okay, so removing all of that. Oh, why can't I paint? Oh, I have to select something, right. Let's erase all of that, and let's create, I don't know, somewhere here, let's create what we need. So to make it make sense, I will probably also need a stairs definition, because we will be going up. So I will add another element here, and I will call this stairs. Make it, I don't know, maybe pink. And then we need to find the stairs which are defined not here, not here. Floor detail, floor B, dungeon. As you can see, there's a lot. Pipes. Where is it? Tileset house. Yeah, here you can see we have the stairs. So going to Tileset house, and these are the stairs that I would like to use. So going to paint stairs, and I'm going rather quickly here because this is like work that we've done already. Okay, and with that we can start playing a little bit. So let's go to our, let's see, this is matching perfectly, so this can be placed in the ground. So let's start by creating some stairs. Okay, and here we will be going up, and then we'll create a snow ridge. Sorry. Snow ridge wall, and it's not defined correctly. Oh, I did not finish painting it. Okay. Okay, I can create the wall like this, and as you can see, everything is auto adjusting pretty much correctly. And then I can create snow ridge, but we will need to fix it a little bit. Right, this is all correct. The one problem we have is that what we see behind here is not correct, but can be fixed very easily. So let me see. I'll create the oh, this is incorrect. To main Control Z. Okay, so I will create the snow ridge wall, and I will create the snow ridge. Okay, this is perfect. The one thing that is missing are the stairs. I will add those to another layer. So let's paint those stairs here. Okay, and now we have a perfect stairs and some height here. Okay, is there anything else I would like to add when it comes to ground? I believe this is pretty much it, right? In the next section, I will focus on making this, well, just looking good enough for us to use. Okay, so in this section, we'll just create a simple level for our game. It will be limited by the water, so we don't really need that much. So yeah, we have the reach here. What I would also like to add is the grass itself. So let me think about this for a second. We were going to light grass. What we're missing here is a full grass tile, right? So this is like this, and this, and this. And what I can do is go to tiles and just select the grass. So maybe like here, and here, and here. And then go to terrains. Okay. And then we need a lot of water. And we will also add a little bit of water here. Okay, so that we have a reason to add the bridge. And I'm looking at this, and maybe we could extend the amount of grass here. I mean, the amount of the dirt patch, and then adding more water. This is very rough. You can, of course, define additional terrains to make more complex level. I'm just doing this for demonstration purposes. Okay, and then we have the bridge, and what I can do is go to tiles, select those and move them here. So we have those and those. So we have a little bit of space to work with, and we have a little bit of decorations. Next thing I would like to add, to not actually make it so empty, is to define some decorations. And this can be done by defining patterns. So let's see. We can do Tileset house, and we can do we can add a few patterns here. For example, this one, this, and this. We can paint it like this, and then going back to pattern, I can just select this and drag it here, and now I can paint with that pattern which is like snowy little decoration on the decoration tilemap layer. So let's see whether there are other snowy decorations that I would like to add. Maybe an igloo. All right, so I can just select it and paint it. And again, if I would like to make it reusable, just select it and drag and drop it here. Okay, for my dirt patch, I'm not gonna add too many things. Maybe here for the green part, we could add some trees. So that's gonna be Tileset nature. Let's bring it down here. And let's see, I'd probably like to add, oh, let's go to tiles. Maybe something like this. I can paint it and I can also treat it as a pattern. Perfect. What else? Maybe, oh, maybe snowy tree. Add it here. And this is, you know, something you can figure out by yourself when it comes to how many good decorations would you like to see and where to place those. There are many options to make your level pretty with this tile set. I'm gonna add this and this, and maybe, I don't know, maybe a Rocky Mountain here and here. Again, those could be turned into a pattern, but this is really up to you. I'm just, you know, trying some stuff to make it less empty. Okay, maybe something here. And again, you can make it look as rich as you want it, but with this, with use of patterns, let's slap another preset here and here. You can make it as beautiful as you want and as needed. Okay, so this is going to be our very, very simple level that we'll use for the rest of our game. We have stairs, we have the bridge, some water, a little island, if you will, a little bit of decoration. So next section is where we actually get to work and we can start working on our character movement. I'll see you there. All right, I believe in this section we will finally get coding, which is what I love the most. So we need to start by creating new scene, which is going to be our player. So let's go to scene, new scene, and let me adjust the microphone here. And we will use character body 2D. For now, there's nothing there, but we'll add animated sprite 2D. And we need to find our character. The definitions of the assets for the characters are pretty much the same, so it doesn't really matter whether you'll use Mask Ninja or Orange Sorcerer. It's up to you. I believe I went with a White Fighter. Okay. And now I can just do animation, new sprite frames, open those up, and add frames from sprite sheet. So going to assets, sprites, actors, characters, White Fighter sprite sheet. Okay, I will have to adjust things a little bit because there's more vertical frames. I believe this is like 7. Yeah, so now if we change the vertical grid to 7, it matches perfectly. And we will start by adding some definitions. So let's do this first one, and I will add that frame, and we have something to work with. Okay, first thing that we need is a collision shape before we define our animations. So I'll go to collision shape 2D, and as a shape I believe we can choose circle. And this has, like, since this is 16 pixels wide when it comes to our sprite, I will do 7 pixels, and I believe we can move this a little bit lower so that it matches its feet, and that should be pretty much good. Saving the scene, I will put it in scenes. I will just call this player TSCN. Perfect. So now it will be a time to set our definitions and our animations, sorry. And we have like 4 movement direction, so back, front, left, and right. So I'm going to call this front idle. I'm going to say that this should autoplay on load, so that should be our first animation that ever plays. Going back into main level, I can instantiate child scene, instantiate player, and here we go. Here he is, our wonderful hero in our level. Now it's time to define the rest of our animations. So I'll create new one, and I will call this back idle. Again, loading from sprite sheet, searching for this one, right? And they should of course repeat. Then what we have is left idle. So here, and let's see, this is left idle. No, this is left idle, sorry. The top row. And then we have right idle. Okay. Yeah. So this is definition for our idle animations. Next step, we need to set up for at least basic movement. Let's see, what we need is probably a camera 2D that we can attach as a child, and there's not really much that we need here. Let's see, because it will automatically follow us. One thing though is we can adjust the zoom for it, and I believe 3 is a good value for the zoom of the camera. Right, and now if I play it, this should be current. We can see our game on the screen, which is perfect. Okay, of course we cannot do anything as our player is not moving at all, so let's fix that. And I will start by going to project settings, input map, and specifying how exactly should we move our player. So let's define some actions, and this is going to be left, right, up, down, and this is going to be A, D, W, and S. Okay, and this definition is enough to actually actually make us move. So we need to start by finally adding a script to our character body. I'll also rename this to player, and we'll attach a script, and I will create new folder, call this scripts, and make it player GT. Okay, we can basically get rid of everything we have here from the start. This is like a template generated by Godot engine, which gives you basic movement, but we don't need that. Let's see, we are not jumping in this game, so we can just leave the speed set to 100. It's not going to change ever, so we can define it as a const, and then we can write a simple script to make our player move. So let's get direction, and this we can get from a input class get vector, and this is going to be like horizontal minus axis, which is left, negative x, positive x is right, negative y is up. Remember, this is up, not down. The y-axis is reversed in game, and then we have down. This gives us the direction. If we have direction, we say that velocity is equal to direction times speed times delta. Yeah, the speed is defined as this, and then else, if we don't have direction, meaning the user is not playing, not pressing any keystroke, we would like to slow down. So this is gonna be velocity x is equal to move toward velocity x to 0. So this is like deceleration, right? And then velocity y is equal to move toward velocity y 0 speed, I believe, times delta is what we needed. And then in the end, move inside. Okay, let's see whether we can get anything running with that. Yeah, but we're moving very, very slowly, which is not perfect, and this is due to the speed being so low, or the delta. So I wouldn't like to get rid of delta, because the delta time is used to make the speed and movement of your player be the same across all machines. So maybe just spam it up 10 times. Better, but still too slow. Okay, this actually makes sense. So 5,000 it is for our movement. And one thing that is really cool is, as you can see, the camera is following us, which is really, really nice. Okay, let's see how it works without delta. It's gonna be the same, right? Yeah, so we can do delta version or not, up to you, really, right? Okay. I'm gonna do the delta version. Cool, perfect. It feels a little bit smoother. Okay, so yeah, we have the basic movement running. The one thing that is not working is of course any kind of collision which with anything we can just pass through like a ghost. So I believe this should be something that we can handle in the next episode, how to set up the proper collision for our tile map layers. Okay, let's start working on those collisions. So what I will do is I will go to a project settings, general, and search for layer names and to the physics. And first one is going to be player. Second one is going to be ground collision, and then decoration. And this is what we need for now. The easiest part to stop is of course our player. We can go to collision and set him to be on a player collision and to collide with ground and decoration. That was the simple stuff. The more complex stuff is how should we handle collisions for our layers. So going to ground town layer, ground tile layer, we need to go to a tile set, and here we need to paint, and we need to create a physics layer. Okay, so here we can go create a physics layer, set to collide with a player, set to exist on the ground and collide with a player. And then we have physics layer 0, and we need to start painting, specifically on the tiles that we know that our player shouldn't be able to move across. So mainly this is going to be Tileset water. And let's see, starting from the top, so this, how far our player should be able to move. And actually what could help you in creating that is probably, let me see, should be option to create a grid here. Delete points, expand editor, toggle grid pixel snap. Okay. And then I can define it. Maybe let's be a little bit more granular, right? So this is how I want my player to be able to move for that tile. And let's see whether this actually works at all. So if I find a specific tile, you can see that I am being stopped from moving further. I need to define this for all the tiles. So going to a ground tile layer, tile set, that's going to be tiles water. Again, changing this a little bit, maybe adding a point. Actually, we can be smart and just click it here and then do flip vertically. Perfect. You can do that and say rotate left. And then I can go here and say flip horizontally, and that covers this part. Now let's take one of the corners. Maybe we will need to add a point here. I believe so. Okay, let's add a point here. And let's add a point here. Okay, and then I can just click it and say rotate right. Rotate right. And also you can use a shortcut here, as you can see, REHV, which is very nice to quickly set those shapes. Then for for the corners, of course. I mean for this part, which is also a part of our water tile set. Let's see what can we get here. So I will try and follow those white lines to the best of my ability. If something like this is good enough, then we click here and press R, and we have that part covered. So that is the definition of the shapes for our water tiles, and as you can see now, I cannot move across the water. But it's gonna raise one important problem. We want to be able to move across the bridge, but I don't want to be I want to be stopped on the bridge, but I don't want to block movement of our player because of the terrain. And let me hide that layer, and going to the back, I will enter visible collision shapes when running. And here you can see the problem, right? There's a bridge here that I have hidden, but underneath there is collision shape on my tile set that is blocking me from movement. And how can we handle that? To handle that, we'll create alternative tile. Okay, so going to a tile set, I will do select. Let's find the tile that interests me. I believe this is the one, and also this is the one, right? I will select it. I'll create alternative tile, select this one and create alternative tile, and they are here. I will check the painting for it, and for this I will completely remove the collision layer. Also for this, make sure that the collision layer is clear. Then I will show where my bridge is, and here underneath you can see that those tile sets with collision layer added should be replaced by the tiles without the collision layer, so that we can move across the bridge. So I'll go to a tile map, tiles, select this, I believe tiles water. We have alternative tiles defined here. Click on them and make sure that we are able to paint, and just repaint those here and here. Okay, so now we can move across. So we just use alternative tile to allow us to modify the property of the tile. Otherwise, it's very much the same. Just one of the properties, in this case the collision shape, is different. So now we can go across our bridge. Okay, continuing on that, I would like to also prevent my player from going through the bridge into the water. So let's go to decoration tile map layer. I believe this is no, stairs are here, nature, water is here, and we are using those tiles. So clicking here in the tile set, we have the let's see, the physics layer, right? And we can treat it as, even though it's decoration, well, let's add another layer. This one is going to be for the decoration. So this is collision layer for ground, and this is for decoration. Let's treat the bridge as a decoration. Okay, so we must be smart about this. We have to allow our user to enter the bridge, but then we must prevent him from falling down the bridge. So let's select this one. Let's reset to the default shape, and let's think. Probably I would like as thin as possible layer of protection for the top for the top row of our tilesets, and then going to bottom, the same, just flip horizontally. Sorry, flip vertically. Okay, and that really should be enough to prevent our player to falling down the bridge, right? He cannot go through here, but he can go through here, right? So maybe we could add alternative tiles, because he should be able to walk on the bridge when they're on the ground, right? It only makes sense to do so. So again, going back to decoration layer, I can go to select, and that's gonna be create alternative, create alternative, create alternative, create alternative, create alternative, create alternative, and they are here. Can I move this around? No. Okay, so this is like one column, because you can have different properties changed. Going to a tile map and painting a little bit, I want to replace that, and I want to replace that, and then I'm gonna assume that, and then this one. So I'm just using the tile sets that do not have the collision layer. Oops, not that one. That one. Okay, let's see how it looks right now. Oh, I used the wrong tile here. So let's fix that real quick. It should be the one ending like, oops. Water. That one. Okay, so now I am able to go, but I am not able to go into the water, but I am able to go into a bridge from each side. Okay, so when it comes to our collisions, what's left is to add them to decorations, the stairs, and our ridge. So let's start with the ridge and the stairs. So going back to a ground tile layer, let's go to, this is relief. Okay, and we are using those. So physics layer, reset to default shape, and we can basically set it, we don't need, or we don't need here, so we can clear. Then this and this and this, they should have this lowered, oops, they should have this lowered a bunch, because here is the snow and here you should be able to walk through it at least a little bit. Maybe we can be more precise, and you can see that we can adjust that corner a little bit. Okay, and then flip it horizontally, use it here, get rid of the points and use it here. Okay, so this should set us up when it comes to so, and again, we will need alternative tiles to be able to walk through the stairs. Well, this could be adjusted a little bit better, but I guess this is fine. You can adjust those collision shapes for tilesets and be more precise, more granular when it comes to that. So let's see, to go through the stairs, we need alternative tiles for the top and for the bottom. Let's do this. So here I need to create, let's just select, create alternative tile, and for this one also create alternative tile. Go to a tile map, select, this is for the bottom, so everything here. Oh, not on the decoration layer, the ground layer. Everything here. Let's close this, and I believe we actually need to see this, and here. Okay, that should allow us to go up. And now there's a problem with blocking the movement inside of the ridge, right? We can do it by setting up the collision shape for our stairs. So go into decoration tile map layer. I believe this is in a house. Find the stair tiles. Let's paint the physics layer. Select that. Let's set it up so that we can cover the side of the stairs here and here. Flipping it horizontally here and here. Actually, we can be a little bit more precise, but this not change many things in that instance. Okay, but this should be the collision shape for the stairs. So yeah, now I'm able to go up, not able to go through the side of the stairs. Perfect. Moving on, we need to secure the or is it already set up properly? Yeah, it's blocked by the collision shape of the grass right here, but we can make it better. Just in case we need this, we can go to ground, we can find the relief, and now here at the top, these are the sides that we are using. So let's work on these. So that's the one. Click this, flip it horizontally. Then what we need is definition here, and we need more points here. So basically 2 points to make it stretch properly. Move this here. Okay, flip it horizontally. So we have that part secured. And then the top part, yeah, the top part, just removing those points. And you can right click to remove a point. And then when you see the green plus, you can just click and drag to add a point. Okay. Perfect. We will not fall from our stone mountain anymore. The last part is, of course, adding the collision shapes to our decorations. So going from left to right, let's see what we're actually using. So going to decoration layer, I believe this is the Tileset nature. I can see we are using this one. It will take a little bit of time, but it's totally doable. Reset the shape here, here. I will adjust this a little bit. Come on. Here. Flip it horizontally. Flip it again. It's going to be the same here. And flip it horizontally here. Then we need to take care of those bottom layers. Bottom tiles, sorry. Let's add some points. This is real quick work. We're just defining where we shouldn't go. Here, flip it horizontally here. And for that one, I believe we're good. Okay, so we got those three sets of trees covered. Then is the trunk. Okay, let's reset this. Let's see how this can be adjusted. Again, you can be as precise as you need for your own game. Adding more points is fine. I'm just trying to go quickly through all of this, as this is rather not so complex and repeatable. Is that the word? I don't know. work. Okay, we have that case covered and something crashed. But that happens when you're using a beta version. Nothing to worry about. Let's see. That was decoration layer, and that was nature, and we were Tileset, painting, physics layer for decoration. Oh, you can see that this I painted this on a layer that's supposed to be for the ground, but in that case these are interchangeable, so it does not matter. Going to the proper physics layer for decoration, wish I could name those, but hey, I don't know how. Edit layer names. Yeah, it doesn't help, right? Decoration should be here. Okay. Yeah, now it's correct. So again, going through our trunk, positioning everything around the places when we need it. Let's see. Can I rotate this? Oh, it's not good enough. Okay. Bring it here and here. And then flip it horizontally here. Maybe adjust it a little bit. So now if I move my player, I shouldn't be able to go through the trunks. Perfect. And through the trees. Okay. The same goes going to the right. We need to add this for rocks and for other decorations. So decoration map layer, nature is gonna be all the same. So I'm just doing it for the video to be complete, but you can definitely do it on your own. I can adjust this a little bit. You can speed it up on YouTube. Yeah, other than that, we're good with that. Then we have stones. Okay, we have a big stone. Let's see here. Here and here and here. And again, do it on your own. Just don't bother with placing the points exactly as I do. This is just very rough work to make it semi-functional. Okay, that covers the rock. What else do we have? Some stuff, some snowy stuff. So let's see, singular snowy tree. Then we have the, I believe this is house part. We have a green snowy column. This is going to be rather simple. And we have, let's see, we have igloo. And this is this one. Maybe being a little bit more precise on those corners. Okay. So now we should collide with the decorations properly. Hey, and we have that working. Okay. Next step, I believe we should handle the movement animations for our player, right? Because now he walks like a stick, or he doesn't walk at all. He's just sliding across the screen. So I'll see you in the next section. Okay, so the next step is to figure out how should we animate our player moving in a proper direction. So going into character body, which I will rename properly to player, and into our code, we will actually split it up in two parts. One will be entirely responsible for animation, and the second part for input and movement. So the player node will be responsible for the movement, and then I made a sprite for the animation. So what I will do is I will add a script here, and I'll move it to scripts, and I will call this animation controller. Okay. And I will create a class name for that. Animation controller. Perfect. Now, I'll need the reference for this in my player. So let's add a class name here too. And let's grab the reference by simply clicking, pressing Ctrl and dragging. Okay, this animation controller, perfect. And then here in our movement, we have to decide what type of animation should we play. So going into sprite frames, let's define our back walk, front walk, left walk, and right walk animations. So clicking here for add frames from sprite, let's find this. This should be in White Fighter. Again, I don't know why it doesn't remember that the number should be 7 here. So let's start by front. I believe these are jump animation, or maybe def, I don't know, but our walk animation, front walk. So we start from here and we go through 4 frames, 1 2 3 4. Okay. The speed of the animation can be 5 FPS and it should loop. Oh, sorry, I overridden the front idle. Let's create front walk. Again, here we don't want this. Add for frames. Okay, if we go to 2D and if we press play, we can see the simple walking animation. Very good. Then we need to add another animation for backwalk. Okay, again, going to sprite sheet. This should be backwalk, so 0, 0, 1, 2, 3 for 4 frames. Playing this, it looks similar, just from other perspective. Then we need to add right walk, and then we need to add left walk. So for left walk, we're starting here. 4 frames. And the right walk, 4 frames. Perfect. So we have the definitions for all of our animations. And then we need to start working on our animation controller script. So we have to have a definition of how to convert from idle animation to walking animation. Okay, now we'll create a dictionary here. Movement to idle. Instead like so. Backwalk, back idle. And again, all of this, which I will set up by hand, could be achieved with animation tree, where you define the transition between animations. In our case, the animations are so simple that it can be set up by hand just by specifying that the back walk should always transition to back idle and back idle to back walk. Front walk to front idle, right walk to right idle, left walk to left idle. Okay. Now what we will do is we'll define two functions here. Function play movement animation for velocity in vector 2. If velocity x is greater than 0, play right walk. And if velocity x is less than 0, can I maybe bump up? Okay, let's adjust the font a little bit so you can see it better. Then play left walk. Yeah, if velocity is greater than velocity y is greater than 0, then do play front walk. Else if velocity y is less than 0, play backwalk. Okay, and then we need to figure out how to stop it and how to play idle animation. Play idle animation. And this is rather simple. We can say if movement to idle keys. So these are the keys that we define for this dictionary. So if array of those keys has the name of currently running animation, play movement to idle animation. Okay, so if currently running animation, for example, front walk, is defined here, then play the value of that dictionary where the key is the name of that animation. So if currently playing animation is front walk, then movement to idle with key of front walk is equal to front idle. Okay, we need to use those functions where we move our player. So here, if velocity is not equal to vector2 0, I can say animated sprite 2D, play movement animation, velocity, else animated sprite 2D, play idle animation. Let's see whether this works. And it is almost good, but I can see that we're not playing the the stop animation, right? We're just stuck. Yeah, we're just stuck working. At least we are for something is wrong with the right definition. So let's see here. XX back walk, front walk, back, back, right, right, left, left. Okay, let's check the sprite frames. So this is, oh, right idle is empty. I don't know how this is possible, but this is the right idle. And I guess this is what we were missing. Yes. And then if we walk, we walk. If we stop, we stop. And we have our movement set up for us. Perfect. This is really, really good. We have the possibility to move in our game. I believe the next big part is working on our inventory. So we need to define the items that can be picked up. We need to define the inventory, the UI. So there's a lot coming in when it comes to that, but we will start working on our items and our inventory in the next section. Okay, so to start working on our inventory item, we first need to be able to pick up something from the ground. And if we go to sprites, items, you can see there's a lot of possibilities for us to use. We have like food items, which we can use for, I know, healing, treasure, and different type of weapons as a sprites. So what we will do is we'll use something called resources, which are like scriptable objects in Godot to actually make that work. So I will create new folder, call this resources. Okay, and I will start by creating new resource of type resource, and I will call this gold coin. For now, it's simply nothing. It's just empty. It doesn't hold any information. But this can be treated as a container for different type of information for our game. So to make that work, I will actually create another script, and I will call this inventory item. And let me real quick explain to you how this will work. So what we will have is a pickup item that you can see laying on the ground in our game world, in our 2D map, right? Once you pick it up, it will be transformed into inventory item. So we'll have an inventory, something simple, basically few slots are different thing, I believe. Few slots that you can fill in with item, and here it will become an inventory item. But then it can contain another type of information which we will have displayed in on-screen UI, which is like weapon item, because maybe this is some kind of weapon that you can use to fight. Okay, so we have pickup item, inventory item, and then weapon item. And this is a node, and this is a resource containing another possible resource that we'll use in our inventory system. So this is basically how it will work. And this is going to be a node, as I said, and these two are going to be resources. So let's get cracking. Scripts, inventory item. It will not extend a node, it will extend a resource. And we'll call this inventory item. And what we'll work with is few things here. One is the amount of stacks, because for example potions or gold can be stacked up to some limit. For example, you can have like, I don't know, 100 or 1000 of gold in each inventory slot. So by default we'll have a single stack. We will also put an information here whether this can be equipped and how. So possible equipment slots are right hand, left hand, potions, and not equipable. For example, gold is not equipable. And we have slot type of string, which is equal to not equipable. Okay, so maybe I drop that down. I hope I can. Then what we'll have is ground collision shape, so that we know how given pickup item with that inventory item should collide with a player. It's gonna be rectangle shape 2D. We'll have a string, sorry, for a name. Texture, side texture for when an item is presented from the side. And that should be export. Maximal stack if item is stackable. It will have a price because maybe we will implement some simple merchant like shop system. Okay, so this is the definition, and then I can go to my gold coin, and here in the script I can say that this is inventory item, and we need to define some stuff for it, right? But to actually use it, we need to also create a node that the player can pick up. Okay, so let's do this. Going back to 2D, we'll create new scene. That's going to be area 2D, and let's call this pick up item. Paste it in scenes. Let's change the name here to pick up item. That should be capitalized. Okay, and let's add all nodes that we need here. So we will need a sprite 2D, and we will need a collision shape. Okay, and it's going to get a little bit tricky because we need to define the separate collision shape and sprite texture for each item. So we kind of have to do it by hand, but don't worry, it's going to be fine. So for the sprite, let's first search for gold, and we have gold coin. So I'm going to use that, just dragging and dropping it so that I can see it. And now, given the fact that I know the dimensions of our sprite, I can add a collision shape. So new rectangle collision shape. And let's try to roughly match it. I believe this is fine when we want to collide with the gold coin. And what I will do is I will save it. So in resources, in gold coin, right, I will improve organization here. So I will do gold coin okay, and then I will, in gold coin, I will do, what are we doing? Yeah, we're saving the shape. Resources, gold coin. I will call this gold coin collision shape. And I will also move the gold coin there. Okay. And yeah, then I can start filling out the properties of my resource. So ground collision shape, gold collision shape, name, gold, texture, well, it's of course the gold coin. Price is 1 because 1 gold equals 1 gold. Max stacks, let's say 100. And this gives us the basic definition of our inventory item. The problem is that it cannot be picked up yet, but this is like an easy fix. So let's actually go to project settings and create another layer for 2D physics called this pickup item. In the area, we'll assign it to layer 4 and make it collide with player. And then we need to basically write a simple script for it. So moving to scripts, create a pickup item script. Okay. So let's start by saying that this is a pickup item. And we do know that it has to export inventory item. Okay. We need few references. We need a reference to sprite2d. We need a reference to collision shape. And with that, we can assign the sprite2d texture the information that we have in our resource. And then collision shape 2d shape is equal to inventory item ground collision shape. So the shape for when item is laying on the ground. And with that, I can go to 2D main. Here's our player, and I can say instantiate child scene, pickup item. It's here, right? And we need to provide the inventory item, because if I play this now without providing the information of the resource I would like to use to fill the data for our pickup item, you will see that, yeah, we'll have an error because we did not provide the inventory item. Okay. So going back to 2D, I will simply provide gold coin here as inventory item. And as you can see, it will work out of the box. Of course, we are not picking it up yet. We have to implement at least the basics of that to our player. But this can be done really easy. So let's go to our player, and we will start by adding area 2D for player to detect the collision between the pickup items. So we'll have two types of collisions here. The basic collision shape that we have here is used for the movement to avoid the collision with tile collisions or decorations, and here we'll use this to detect overlapping with some items. Okay, so what we will do is add a collision shape to our player, and actually what I could do is save that circle shape 2D as, let's see, it's resource player, call this player collision shape, and then I can simply reuse it, right, and bring it down a notch. Okay, so with that I can connect to signal here, and this is going to be, remember that our pickup item is an area, so we want area entered. Connect to player on area entered. Okay, we can do a simple check. If area is pickup item, I can say area QE3. With that, it doesn't work because we need to give our player the possibility to collide with pickup item. And it still doesn't work. Let me see what we're missing here. Layer 4, mask 1. We do move and slide. We have that connected. Okay, so what we're missing here for it to work is, of course, we set up the collision for the player when it comes to colliding with stuff, but I did not set it properly for the area, which is like for detecting things. So of course it should be masked against layer number 4, which is pickup item. Now if we try and run it, I can actually pick up the gold piece. So this is the very basic start of our inventory, and we will extend it in the next section where we will start working on things like the inventory system and inventory UI. Okay, so let's quickly discuss how our inventory system, inventory UI will work. It's gonna be 8 grids, but we can extend this because this is going to be configurable, and each is going to be inventory slot, and each of the inventory slot, it will be a separate scene, and we can click on any slot to like activate it, or maybe to expand some kind of menu with set of actions to perform for a given slot. For example, dropping an item out of the inventory or equipping it. So first thing that we need to build is actually inventory slot. That's what we are going to do right now. So we need to create a new scene, and starting it with we want to make inventory slot, right? So this is going to be actually a vertical, sorry, VBox, yeah, VBox container. Okay, let me save this, and we will go to scenes. I'll create new folder, call this UI. Here I will change it to be inventory slot, and we need to start adding some stuff. So first thing I want to add is 9 patch rectangle. Basically, if you don't know what 9 patch rectangle is, it is like expandable UI border, and we have something like this in our case, and I believe this is called face set box. Yeah, face set box. So let's grab it and drop it here. Okay, we need to specify custom minimum size in the layout to be 60 and 60, and we have that presented here already. Yeah, so this is going to be the background for our inventory slot. Going farther, we need a menu here, and this is going to be a menu button, and we will make it span across the whole inventory slot, and we will use it to basically use the right click to expand the menu, just like in Tarkov menu, so maybe I can show it to you. How does it look like? Yeah. So what we want is something like this. When you click, right, you should have your drop-down menu with different set of options available. So that's why we need menu button for. Okay, then what we need is a center container, and it will also span across. And then we need a texture rect here. And I need it to have, and this actually is going to be the place where we display the item icon, and we need to set the proper properties for it. So we will set it to fit with and keep aspect centered, so it always looks good inside of our container. And for layout, we give it 40 and 40 custom minimum size. Okay. Then underneath our main button, we add a simple button, and I will call this on click button, because there will be two options here. With our inventory slot, why don't I see it? Oh, okay, not what I expected. And so we have our inventory slot, and when clicking the right mouse, you will get that expandable button. But there's also a scenario when we want to perform some kind of action just by clicking once somewhere in the icon. So we will have two kinds of actions: right click and just simple standard left click. And that's what we need. Okay, so this is going to cover the case of the left click. So we have on click button, and there's nothing really here. Button mask is mouse left. This is very good, but we need to change the layout and make it 60 by 60. Perfect. And then we will need some kind of informations. We'll add a label to display the amount of stacks. Move it here next to our on-click button. I'll probably place it somewhere around here, with origin being here. Somewhere around here is good, I believe. And then if I press 1, it will display 1. If it's 12, it displays 12. Can move it a little bit more to make it fit into the corner. This is good. What else do we need? We need a label below inventory slot. I mean 9 patch rect, so another label which is going to be it's going to be name label. This is going to be stacks label. And then we will also need for the future price label. The name label is here, and then we have price label. So price label. Okay, and by default this is going to be hidden. Okay, so this is the basic configuration. Let's rename this to inventory slot. And we will need to get coding a little bit. So going to scripts, inventory slot. Okay, let's start by calling this class name inventory slot. We have some booleans here. Is empty, starts by with true. Is selected, it starts with false. We want to know whether this is for single press only, so just for left mouse click. Single button press, it's going to be false. We'll also export starting texture. It's going to be a texture. We'll also set starting label. And we need some references. So texture rect, name label, stacks label, on click button, and price label are all needed here. And we need the basic information for which slot can be given item equipped to. So we'll start by saying this is not equipable. And this goes alongside the inventory item definition. So is the item that we currently have in this inventory slot equipable? If not, then it's not. If it is, to which slot can we equip it? Okay. And we'll write the ready function for now for it, just to fill everything out. Set this for myself, and let me grab a sip of water. Okay, so function ready. If we have starting texture, texture rect, texture should be starting texture. If we have a starting label, name label, text is equal to starting label. Is main button active? That depends. Where do we have it? We have a reference for it? No, so this is main button. Main button. Is it disabled? That depends. If that's a single button press and is on click button disabled, is a negation of single button press. Is on click button visible? This if it's single button press. And then pop-up menu. Yeah, so how can we handle the pop-up menu? That's the question. If we go to menu button here, let's move it here. What we can define is set of items. So what should we present to the user whenever he activates the menu button? And we will have two actions here. One is going to be equip, and second is going to be drop. Okay, those actions we'll use from our drop-down menu. So now, how to handle it? Well, it's rather easy. Our pop-up menu is menu button, get pop-up, and we need to connect to a signal. ID pressed, connect, on, pop-up menu item pressed, and we'll just write that function. Alternatively, I believe we could connect to this one, right? Base button. So that should be the same, but ID pressed. Let's see, can we have it here? ID pressed. Not even that, because we need to get access to pop-up. Okay, so let's write that function real quick. So on pop-up menu item pressed gets us ID of type int, and for now we will leave this as printing print debug ID. Okay, nothing fancy here, but we needed this configuration to create that reusable inventory slot. In the next episode, we'll continue working on it by actually creating the inventory UI that we can open and close. So I will see you in the next section. So now our aim is to actually create the inventory UI that will use our inventory slot. So we need to create a new scene, new scene, and as a root I will use canvas layer. Let's see. We are looking for inventory system, player UI. Okay, we can call this player UI, inventory UI. I'm thinking, yeah, inventory UI. And let's save it in the scenes. Perfect. And what do we need here? First, we'll add color rectangle. We'll make it span across. So take all of the available area. And we'll change the color to black and semi-transparent. Okay, that's perfect. And we will plug it in our player. So instantiate child scene, inventory UI. Okay. Let's see. By default, it should be hidden. And then we need to define an action to actually trigger it. So toggle inventory. Let's see, project, input map, and let's say toggle inventory. And as an action, I'm going to use tab. Okay, so now what should we do? We'll create a separate node that will handle all of the inventory actions, but not in the inventory UI. So to maybe show you how it works, right? We'll have a UI of the inventory, which handles everything when it comes to displaying stuff. And then we have a separate inventory system script that handles the data. So this is the data, and this is the presentation. And of course, handling the user actions like clicking on a given inventory slot, right? And they just talk to each other. So I will create an empty node here and call this it's inventory. And I will create inventory script here. Go to scripts, inventory. That's perfect. And here, there's one thing that I want to handle for sure. So let's add a class name, inventory. And I want to handle the input event here and say if input is action just pressed, toggle inventory, then we'll toggle the inventory. And how do we do this? We go to inventory UI, we go to attach script, and here in inventory UI, we will create a simple toggle function. You can say toggle, and I will say visible. It's not equal to visible. We'll trigger and toggle the visibility. That's the other class name. Then I can go back to my player, to my inventory, and I will say you need a reference to inventory UI, and if that action is pressed, just do inventory toggle. Perfect. And with that, if I run everything and I press tab, nothing really happens. Let's see. Oh, I will actually need to place it here. Inventory UI toggle. Okay, I don't see it on my screen. Let's go to remote main player. Inventory UI is still hidden. So it should do that. Let's try this again. Oh. Okay, self-visible. If I trigger it, let me actually check it real quick. Pump it up so that we know for sure. Yeah, it doesn't seem to have any effect. Let's go to player, make it visible. Yeah, and now nothing's really happening. Of course, this is my bad. It should be like this to switch the value, not to compare them, right? So now I can toggle the inventory in and out. Perfect. And we will actually start it as not visible, but we need to build it further. Okay, so what we need is a margin container. Push it off of the edges of the screen. Let's go to theme overrides constants. 64. Okay, and then we'll do 9 patch rect, which is the easiest way to create a texture with a border, and we'll do dialog box face set. And we need to add the patch margin here. So based on the texture we have, I believe that these should be 6, 6, 6, and 6. And then do we need to edit region? Yes, we need to edit the region because we don't want that part, and we only are interested in this inner like kind of orangey part. So let me move this to match to what we need. Okay, I believe it's not perfect. As you can see, there are some parts missing here. Move it a little back here, then close. And then when we go here and set the value of it, sorry, this is 9 patch rect. This has to spread across. Okay, you can see it isn't perfect, but we have some kind of border. The problem with it, it's not gonna look perfect, and this is due to the fact that this texture, right, it has that part here, it is more for a dialogue. I just decided that we can use it to build the UI. So now if we run it and trigger it, we have this nice window in the center of the screen. Okay, moving further with our inventory UI, we need another margin container. This time it's going to be 32. It should also span across to push the to create like a padding inside of our margin container, or sorry, in our 9 patch rect. And then next step is like stacking things in a column. So we need a V box. We have a label here. We'll have our grid with inventory slots, and then maybe something extra at the bottom. We'll see. Okay, so I'm adding a V box. Okay, and first thing is going to be inventory label. So a label, and we will actually use inventory text here. It's not very visible, but I will create a theme here, and let's see. what I would like to do is create default font here, and we have I believe this is Wild Breath of Zelda. So, and we can create default font size, which is going to be, we need like more, this is too big definitely, because it's going to be applied to all elements. Zero is like default, okay, but here I would like to override it. So font color is black. Let's see, text alignment is center. The font size, I would like to make it, how big is it? Actually 64. Oops. Font size 64. Okay, so we have that. Now it starts looking like an UI. Perfect. And I will add a grid below so that we can fill our inventory slots here. So grid, columns free, layout, let's see, container sizing, we'll do shrink center and shrink center. Okay, and this we will use to actually create inventory slots. So going to inventory script right now, we need some informations here. Let's move this, make some space. We need the reference to grid container. And as you can see, this is creating a long free path to reach that node. So I can just right click it and select access as unique name. That's way better. And we need our inventory slot scene. So I will just simply preload it. I will call this inventory slot scene. Perfect. And then we need size. So export. We need two things here. The size, meaning the amount of slots, which is going to be 8, and columns number, which is going to be 4. Then we need just to fill it out. So function ready grid container columns is equal to columns, and for I in size, so we'll loop var inventory slot is equal to inventory slot scene. We'll instantiate it. I hope it knows what it does. Grid container add tiled inventory slot. Okay, let's try running it now. And we have our inventory slots present on the screen. One thing that I would like to change for now is remove the stacks number. But here we have very simple, stupid simple actually, slot-based inventory grid. So we'll actually work on putting the stuff when we pick it up from the ground, as you can do now with a gold, into the slot in next section. I'll see you there. Okay, so in this section, we will continue our work on inventory system. and it will start in our player here where we collide with the area that is the pickup item. So here we need the reference to our inventory system. So let's grab that, and I will just call here inventory add item, even though we don't have that function defined yet. And we'll pass inventory item and the number of stacks, right? And as we can tell here in the inventory item, I believe we are missing the number of stacks. So let's see, we have inventory item. Should also, or should we, because inventory item has max stacks. Yeah, inventory item also has stacks, so that should not really be needed. Let's go to our inventory system and start working on adding the item. So it should be function add item, item which is of type inventory item, and stacks should be int. So for now, let's just print the back item name if we collide. Okay, so I'll try and run it, and I get there and invite access property of key stacks on area pickup item. Yes, of course, because we did not define it. Oh, of course, it should be in the pickup item. So here we can add this. Let's do export var stacks int 1. And with that, if I go to 2D and to our main, and I click on my gold, I can say that, for example, this pile of coins is actually like, I know, 12. Okay? And with that defined, I can just now, it should now run properly. Okay? And here I can see that my name is being printed into the console, which is just wonderful. Okay, we can build on that, continuing with our inventory items. So there are two things to handle here. There are types of items that are stackable, meaning you can hold like, I don't know, 3 potions or 100 gold in one place. And the items that are not. And we have to handle both cases. Okay, so if stacks and item max stacks is greater than 1, we'll create a function here and call this add stackable item to inventory, which is the case when we have item that stacks. And we pass the item and stacks. And then we will have second scenario where we just add a standard like normal single item to inventory. So let's handle this because it's going to be a little bit complex. It's of course again inventory item and stacks is int. Okay. We need to figure out whether we already have that item in inventory. Because if we have an item in inventory, let me just paint it for you. Where's my cursor? Let's change it all to black. And why can't I? Okay, so we have item that stacks, for example, to 100 stacks, and we have inventory slots. Okay, and for example, we picked up 12 stacks of gold. It should go here with a 12. But then what happens if we pick up like 101, right? This should be filled up to 100 because this is the max stacks, right? And the rest, which is 13, should go here, right? So we have to figure out whether we already have somewhere in our inventory slot given item that stacks. If we do, we need to check whether we can add to the slot that we currently have. If not, we need to fill the next slot. So this is a little bit complex, but we can figure it out. I will add some comments here. So let's check. Is item already in inventory? Oops, sorry for caps lock. And we have to reverse search because we're trying to find the last item slot that was not filled with that item. So actually, probably if we do the front search in that direction, the slots are already filled in with a maximum amount of stacks. But if we do reverse search in that direction, we might be able to find the first slot which has a higher probability of not being filled up to maximal amount of stacks. Okay, that's why we reverse search. So let's do item index and set it to -1, which is an indicator that we do not have that item in inventory. And then for I, in items size, we'll do if items but I is not equal to null, and we compare by name, items I name is equal to item name, item index is equal to I. Assign that allowed? Of course it's not allowed. Okay. And the identifier items not declared in current scope. This is correct because we need to have an array of items that we currently have in our inventory. So this is array of inventory item, which starts as an empty. This represents the items in inventory. Items currently in inventory. Okay. Okay. So now we know whether we found that item and its index or not. And then we have two scenarios. If item index is not equal to -1, so we found that item, we need to add stacks to that item. So add stacks to found item. Okay, so the inventory item in our inventory is items at item index. We need to check, can we add current stack to item in inventory? So if inventory, oops, if inventory item stacks plus amount of stacks that we want to add now is less than equal item max stacks, then we can simply add it. Okay, so I can say inventory item stacks plus equals stacks, and then items under item index, we need to pass this back because we updated the information about the amount of stacks. And here we just write simple to do update the player UI. Okay, the second scenario is where we know we cannot update the update given slot completely, and we need to open like the next stack. So this is the case where we have 88 here, we are adding 30, right? We need to fill this up and then pass the leftover to the next stack. Okay, so we need to find the difference that will be passing into the next inventory slot. So let's do something like this. Else stacks diff, and this is going to be inventory item stacks plus stacks minus item max stacks. Additional inventory item, so the item that we need to add as we open the next, as we fill out the next inventory slot, is inventory item, and we'll just create duplicate and pass through here because where is it? Yeah, we want to get a deep duplicate of that item, meaning like completely new separate copy that we are able to manipulate and change. So we have a duplicate now, and I will say inventory item stacks is equal to item max stacks. Here we add a to do update the player UI. Then we need to say that this additional inventory item stacks is equal to stacks diff, and we append that item to our array. Additional inventory item, and here again we need to do update player UI with new item. Let's see. Okay, small typo there. Okay, so this is how we can handle the stackable items whenever we need to wonderful coffee. Whenever we need to add items that stack. Of course, we will not see it yet because we don't have a player UI set up, but there's the other case that we need to handle, and this is the case where we simply did not find item index. So this is something new that we're adding with given amount of stacks, and this is rather easy because I can just say item stacks is equal to stacks, items, append item, player UI. We don't have it yet, so to do again, update the player UI. And you can see that we have those to do here, and well, this is of course planned. This is what we wanted, because we are separating the visual layer, the inventory UI, from the data layer, which is just the inventory. As you can see, here is the data, and then the representation of it will be handled in inventory UI. Okay, perfect. So this is a case of handling the stackable item. What about handling the item that does not stack? Well, this is rather simple. So let's see. There's nothing really crazy here. We need to find first empty slot in our item inventory. And the question is whether we actually can do it. Let's see. I believe that scrolling items, append item should be enough. And then of course we need to update the UI. Also, one other thing that I would like to keep track of is the amount of slots that are taken in our inventory. Yeah, and this is going to get a little bit more complicated, but maybe let's leave it for now. That should be enough. So to test this, we can go to main, and we have the pickup item, and I'm going to duplicate it, right? And let's see, for our gold coin, the max tax is 100, okay? So what we will do here is I will set this one to be 88, and I will set this one to be 20, and this one, which one is it? 12, and okay. So what I can do is I can pick this up, go to remote, player, inventory, and I can say that I have an array here, and it has 88. Oh, this is remote resource, sorry. I can go to inventory. I can see that it has just one size, right? And then if I pick up the another and another, inventory now has two, a size of 2, which means that our gold actually stacked pretty well into 2 elements. I would love to, yeah, you can see that this is 20, and then this one should be 100, right? Because if I go here again, this is 88 plus 20 plus 12, which is 120. So the items are stacked correctly, which is great. Okay, next thing that we will work on is the player UI and its visual representation of the items that we have in inventory, and then we will start working on weapons. So I see you in the next section. Okay, so we are able to pick stuff up from the ground, and it goes to our inventory, but of course we do not see it in the player UI. So now would be a good time to actually address that. Let's start by going into our player UI, inventory UI, and writing a simple function that will be needed, which is of course add item. So what we need is to find first empty slot. Okay, so let's get the slots grid container, get children, and then we need a filter function, and for each slot we are searching for slot is empty property, but of course we do not have that one defined. So let's actually go and write it. We have that property? We should. Inventory slot is empty. Okay, so we can filter with that. Perfect. Going back to inventory UI, we're searching for first empty slot. So what I can do is just call first empty slot should be on the front. So first empty slot is slots front as inventory slot. And the front function returns the first element of the array, which is really nice utility function. And then for the first empty slot, I will call add item. Okay, the one problem is that we do not have this defined, right? So going into inventory slot here, yeah, this is of course not defined. We need to write that function. So, oops. Add item, inventory item. And then we need to decide how it should behave. Some water there for me, because the items that are equipable will behave different than items that are not equipable. Okay, so first we need to decide that if item there's slot type, it's equal to not equipable. I believe that's the word, right? Yeah. So this is like, I don't know, you cannot equip gold, for example, right? This is good example. Oh, this is not equipable. This is not equipable, meaning it is equipable. So this is for like weapons or I don't know, potions. So pop-up menu is equal to menu button get pop-up as pop-up menu. Or maybe can we actually do it? Yeah, we were able to do it like this. Cool. Let me get some space here. So for the pop-up menu, we can get to which slot can we equip it. So equip slot name array. We can get it by getting the slot type, right, and maybe splitting it, right, because I specifically defined it with the underscore here so that we can split by that underscore and know whether we should equip to right or left hand. It will all make sense in a second. So this is going to be, oops, what is going on? Okay, this is going to be item slot type to lower split. Okay, and equip slot name is equal to, you can join an array of strings by using empty string and calling join on it. Okay, and slot to equip is going to be equal to item slot type, and then I can say pop-up menu set item text for first element in our pop-up menu. We can say equip to, let's add a space, equip slot name. So just to explain to you how it will work, if we have a slot and we pick up something like, I don't know, like a sword, I cannot draw for shit, but this is a sword. If you right click it, you will see a pop-up menu, and here, for example, you will have a precise information like equip to left hand, because, for example, just like in, I don't know, Baldur's Gate, you cannot equip a shield to your right hand as a main weapon. So we will know whether we are equipping to right hand, whether this is the right hand or left hand, right? That's why we're doing all of this mambo jumbo. Okay. For all other items, whether they are equipable or not, we set the slot to be not empty anymore. We say that main button is disabled, is set to false. Texture rect is actually item texture, and again, this is like us going from the item laying on the ground, which is the pickup item, which has the resource, and then it goes into our inventory system, and the data from there is being represented in our inventory UI, right? So the resource here has information about texture, and we pass it all the way to inventory UI through inventory system to finally display it on the screen. Okay, so we have that. Name label text is equal to item name. If item stacks is less than 2, we return, because we don't need to represent the amount of stacks if the stacks is 0 or 1. Well, 0 makes some sense, so 1. Otherwise, we do stacks label text is equal to convert to string item stacks. Okay, it looks like it might have some sense. So let's see. I pick some gold and nothing happens because do we even call that function in our inventory system? I'm gonna guess probably not. So let's see. When we add item here, we need to call player player. Oh, we don't have the reference to player UI here. No, inventory UI. Sorry, I keep messing up the names. Inventory UI, add item. Okay, that's one thing. Then going to our stackable item, right? Here we need to do player UI. Sorry, inventory UI. Add item, additional inventory item. And here also inventory UI, add item. Okay, these two cases are a little bit different because we are updating the amount of stacks rather than adding a new item to inventory. So let's try this. And we have 88 gold, even though we probably need to fix the label because it looks really, really bad. So go to inventory slot. This is the name label. We'll center and center. Let's see. I think we have a theme defined somewhere with the default. No, we don't. But I think we do. This label, does it have? Yeah, it has a theme, so let's save it. We can go to resources, new folder UI, call this theme, okay, and then we can reuse that theme to make sure that we have the very same font, okay? So you have that, the color is black, okay? Let's run it again. Yeah, now we have 88 gold, and this might be more readable. Maybe we could do for the stacks label. Let's see. I will load the theme and I will do font outline. Maybe it will improve the readability. Not really. Font shadow. It's a little bit better. But here you can see that we have our gold in place. The problem is though, the scenario with the stackable items, if we pick it up, yeah, you can see it is being displayed incorrectly, right? So we need to handle that case. It is correct when it comes to data. It is not when it comes to the representation of the data in our UI. So what we need, let's just close this. So what we need actually is another function, and we will call it update stack at slot index. Okay, so this is when we're stacking items. So update stack at slot index, and it gets the stacks value as an int, and it gets inventory slot index as an int. And if inventory slot index for some reason is equals to -1, this is just to prevent strange bugs. Otherwise, we grab that inventory slot, and we know this is inventory slot, and we do inventory slot stacks label text stacks value. Okay, let's check this. 1, 2, and this is 88 and 8 because of course I created a function that I do not call. So going back to inventory ID, inventory system, here I believe is a place to, we are updating the stacks. So player inventory UI, update stack at slot index, inventory item stacks item index. And then here also we pretty much do the same, except for the fact that we do, oops, we do max stacks in that case, because remember, this is the scenario where we fill to the maximum amount of stacks the previous slot that already has an amount of items, and then we open up another slot. Okay, let's try this again. Yay! And now we can see our stackable items working, which is great, which is wonderful. Okay, next thing that we will work on are items. So what we're going to prepare in the next section is, like, I don't know, 2 types of weapons and maybe a shield, and we'll see how it goes. Then we will add animations for attacking, yeah, and that would be, oh, and then also dropping items. So yeah, there's still a lot of work when it comes to our inventory. See you in the next section. So in this episode we will work further on our inventory system by introducing weapon item. So it's going to be a resource that can be used to actually implement some kind of basic Zelda-like fighting system in our game. And what we will do is we will start with a new type of resource, but first let's check what we can use in terms of assets. So going to sprites, items, weapons. There's a lot, and most of them can be used, right, to actually fight. They can have different statistics, but I will try to keep it as simple as possible. So I'm going to start by creating a new script. I will call this weapon item. Okay, let's open it up. It's gonna extend resource. And getting rid of all of that. We'll say this is, oops, this is class name weapon item. And we will export everything that is needed for us to set up the item. Some properties I will like left for you for implement, because I'm not gonna make, like, you know, 20 hours course for that, because that would be too long. But we will have in hand texture, just like texture. We'll have side in hand texture for when you would like this to appear differently from the side than from when attacking top to bottom. We of course need a collision shape. We need an enum here between melee, ranged, and magic to specify the attack type. So I don't know, maybe magic has some kind of different effects, right? And then we can group exported stuffs to make it appear nicer and more concise in UI in the inspector. So I will export group. It's going to be attachment position, and we can close this with export group and empty string. And here we need to specify, let me show it to you, because if this is our player, right, he can face each direction, left, right, top, bottom. So we need to specify when player is in each position, right, how should weapon be attached to his sprite, because maybe when attacking left the weapon should be here, but when attacking right it should be like right here because of the sprite animation. When attacking to bottom it should be here, but when attacking to top it should be here. So we need those attachment positions. So export var left attachment position, export var right attachment position, and this is going to be relative to the player sprite. I call this front, and this is okay. Then the Z index, right? Because then of course also the rotation, right? Because maybe when playing the animation I would like my weapon to rotate slightly to one of the directions. So we'll also use this. Export group rotation. Left rotation. Right rotation. Front rotation. And back rotation. Okay. And then Z index is also needed because when attacking to front, you might want the weapon to appear in front of the player, and then when attacking to the top, maybe you would like to be behind the player. And Z index, if you don't know, Z index is just like the information about which sprite should be rendered first and which should be rendered behind. So the higher the Z index, the closer to your screen is gonna get rendered. So you can set up how do they overlap each other. So another export group Z index, export group, close this, and then we do export var left Z index, Okay. And this, of course, should be int. And if you don't know how I just did that, like the multiple cursor thing, you just hold Alt and click and it places multiple cursors for you. So this is, yeah, this is Alt plus left click. Okay. And then, which is really cool, you can also have the functions defined inside of your resource, right? So I'll create a function called get data for direction. The direction is going to be a string. It is going to be a left, right, front, back. So I can do match direction. And this is match pattern, which is like something a little bit like a switch case statement. So for the left, we'll just we'll return dictionaries here. Then for rotation, okay, and we will repeat the same process for all of the possible directions. Mm, perfect. Okay, and this is the whole definition of weapon item. So what we can do right now actually is to go to resources, create new folder called weapons, and I'll create a new resource, which is going to be I don't know. So let's start with a sword. Okay, let's make this capitalized. And we need two things here defined. The definition for the pickup item, right, for the inventory item, and then for the weapon itself. So let's start with create new resource and this is going to be just a resource. I call this sword inventory item. I will load a script for inventory item, and I have to change it a little bit for our inventory item, because now inventory item is possible for it to contain a weapon item, which is optional, of course. So weapon item, okay. So I will go here, sort inventory item. Okay, there's no item. Slot type, this is right hand, ground collision shape to be defined, then sort. Texture, let's search for sword here. Sort 2. Okay, so this is a sword. Let's see, this looks kind of strange. This is like a standard. So you have sprite and you have sprite in hand, and sprite in hand is for a weapon item. So I would love to just grab that and put it here. Max stacks is of course 1. The price, let's set it to like, I don't know, 90. And then we need to get the definition for the weapon item. But let's start with creating the ground collision shape. I already have one prepared, but let me show you how to set it up. Okay, so we're going to a pickup item and going to 2D, switch this to be sword, and clear this, or let's create new rectangle shape. Okay, about that is good. Now we'll save it here, and I will say that this is sword ground, when you pick it from the ground collision shape. Okay, then back here, you can now pass it right there. Okay, so let's check whether this works at all. So now what is cool is I can say that this is gold, right? This also is gold and it will show us a gold, but here I can just say that this is sword now. And if I play the game, we'll see we have gold, gold, and sword. And I am able to pick up the sword and it shows in inventory, which is really great because we were very smart when setting up our inventory. Okay, so we have that definition done. We are able to pick the weapons from the ground. Now in the next section, we will prepare the definition for the weapon item. So I mean, like, we'll fill out the data and start working on our combat system. Okay, so let's create some weapons and let's see whether we can actually equip them. So we have the inventory item for our weapon, but we don't have the weapon item for our sword. So I will create a new resource here and call this this is going to be resource, and this is going to be sword weapon item. Okay, and I will make sure that I have a proper script for it, which is weapon item. And here we need to start defining some stuff for it. So let me see, the in-hand texture is going to be sprite in hand. We don't need to have the side in hand texture. Attack type is going to be melee, and then the problem that we need to figure out is the collision shape for it, right? But we can hack it with our pickup item. If we pass the sprite in hand, here we can probably work out the collision shape. So let's create new rectangle collision shape, right? Align it with a, oops, align it with the blade, and then I can save it as, let's see, sword, and this is a sword weapon item collision shape. Perfect. Going back to sword weapon item, I can then pass the right collision shape here, and then we need to figure out the position for it, right? So how it attaches. I have the values for it right here. How did I do it? How did I do it to figure out those values, right? What I did is I just grabbed the sprite in hand. I can just drop it here. Can I? Yeah, I can just drop it here, and then I rotated it. All right, and then I manipulated position so it looks good with all of my sprites, right? And that's how I figured out the rotation. As you can see, this would be, for example, the position for the front attack, and then for the let's say left, or that would be minus 90 when it comes to rotation. And then when I was figuring out the the right attack, right, that's how I figure out where it should be when we were attacking to the right. And I just wrote down those position and rotation, and we will put it in our attachment position. So that's how can you do it. So the values here are minus 14 and 4, 14 and 4, 5 and 10, minus 5 and 11. And then for rotation, this is 90, minus 90, 0, minus 180. And for the index, it's 1, 1, 1, 0. So that completes the definition of our weapon item for the sword. Now in inventory item, I can now say that the weapon item is that resource. So we have like a resource within a resource. Okay. So if we pick it up, nothing yet happens. There's no way for us to equip it. So we have to update our inventory UI to allow for the right click. So going to inventory UI, let me see. Toggle spells UI on spell slot clicked. Oh, okay. We need to go to our inventory slot and start working on it. Basically, we need to show our pop-up whenever user clicks on it. So what we will do, sorry, is grab the menu button. You have pop-up ID pressed. So if we go to our inventory and we left click on the sword, we can see that the menu is actually visible, and you have equipped right hand and drop actions. So if I click on the equipped right hand, what is going to happen is on pop-up menu item press is getting triggered. So we need to actually fill out that function. So we need to get the information about what was pressed. So pressed menu item is equal to menu button get pop-up get item, and we get text by ID, and we can check if pressed menu item is equal to drop, then we'll just handle the drop here. So do command to do handle item dropping will else if pressed many item contains equip, because we can equip to left or right hand. Where do we have a space for indentation? Here. Okay. And slot to equip is not equal, not equipable. Is just, I believe this is the word we've used. Let's check. This should be in inventory item, not equipable. Okay. Then we will equip it. And for now, it's going to be very, very simple. And when equipping, we'll just emit a signal, right? So we'll do a signal here. Equip item. And we will say equip item, emit with, oh, what do we want here? Probably ID. No, slot to equip. Okay, yeah. Expected after, oh, here we can just print the back. Okay, so let me paint a picture for you on how this is going to work. We have a slot with a weapon, and this is a sword. And we click equip here. This will emit a signal for the inventory system that will propagate this information to both our combat system and on screen UI to show that the sword was equipped. Okay, so we have that, and then we need to go to inventory UI, and here where we create a slots, right, we need to listen for each slot being equipped. So when creating that, we need to say we add the child, this is correct, and then we say inventory slot, equip item, connect, let's create a function, get slot to equip as a string, right? And we will re-emit the signal here. So we'll create a signal, equip item, which has the index and slot to equip. Okay, and this just calls equip item emit I slot to equip. Okay, so from given slot we go to inventory UI, where we inform, okay, we need to equip something that is currently on I index, and it should be equipped to that slot. Okay, and this should of course be listened by our inventory system. So let's go to our inventory system, and we need to get our ready function. Have a reference inventory UI here, so we do inventory UI equip item connect on item equipped, and we need to create that function now. Let's close this. Oops. So on item equipped with IDX and slot to equip, and now we're able to obtain the item to equip. It's going to be items IDX, and for now I would just say print the bag item to equip name. Okay, let's try this. I pick up the sword, I click equip to right hand, and now here I have information that the equipped item should be sorted. So the next thing is to pass that information to on-screen UI and combat system. So next thing that we will handle is the on-screen UI in the next section. So to present our equipped weapon on a screen, we need to build on-screen UI scene. So let me show that real quick to you. So what we will have is our screen and our wonderful hero here with a sword, right? And then we need to present the, the health bar, for example, and then the things that he has equipped in his right hand, in his left hand, and maybe potions. We'll see. So all of this is going to be on-screen UI overlaying our main game window. Let's get to it. Let's create new scene. This is going to be canvas layer. I'm gonna call this on-screen UI, and let me also stop the game. Let's save it. Go to scenes, UI, on-screen UI. This is fine. Okay, let's go to 2D and let's start adding stuff. First thing that we want is margin container. Make it span across the whole screen. Let's see the values here for the theme overrides. I want 8, 8, 8, and 8. So we have that. Then I'm going to slap a progress bar, which we'll use later as the health bar. But now let's collapse this and let's change show percentage to off, so it's barely visible here. And let's take care of the our slots for our equipped stuff. So I'm gonna do 8-box container, and then we need to add the slots and we need to create a separate scene for that because it's gonna get a little bit complex. One thing though, we can already work on positioning this on screen. So let me see. We need to change the layout. So layout container sizing is going to be shrink begin and shrink end. So it's there. I believe this is all that we need for now. So here, right here, we'll place our on-screen UI containers. And let me just, okay, yeah, this is better, I hope. So you can see my cursor. At least that I can do for you when recording. Okay, so again, scene, new scene, and this is going to be VBox container this time. And I'm going to call this on-screen equipment slot. Save it. First, we will do 9 patch rectangle. Okay, and we need to provide it with the proper texture. And this is going to be, again, we'll reuse face set box. This one, let's drop it. Okay. We need to create 2 things here. I believe this is patch margin. We'll do 8, 8, 8, and 8. And then in layout, custom minimum size is again 60, 60, and 60. So you have something like that. Then since technically it is possible to equip, like for example, I know 3 potions, we need a stacks label. So again, let's add a label. Call this stacks label. And let me position it where I want it. Right here. And I don't even really want to scale it. It's more like let's put it right here and drag the origin here. This is good enough. So maybe just a little bit more like here. Okay, it doesn't really matter, but again, we can load the theme to set the font. Okay, and let's make sure that it's set to center. Perfect. Then what we need is a center container. Make it span across the whole scene. And inside we need to add texture rect. And that texture rect, let's see, can we make it a little bit like smaller maybe? Okay. Let's make sure that it fits the border. Yep, and then let me think, the texture rect. It should be good, I believe. And we need just to set the expand mode to fit with and keep aspect centered. Okay, then this we can add later. And slot label. which is gonna be presented below. So a child node label, and this is, for example, gonna be like R hand to indicate the right hand. Again, center. Set the font. And we need to do the outline. So font outline. Outline size, we are actually going to bump it up to 6. And then, yeah, I believe that's it. When it comes to the size, let me think. Should we play with this around a little bit? Yeah, that looks good. Okay. So that's it, and we need to write a simple script for it so that we can set everything up. So attach script, this should be in the scripts folder. On-screen equipment slot, sounds good. Create, and let's see what do we need here. There's not a lot, nevertheless. Let's do class name on-screen equipment slot. We need some references. Let's call this slot label. Okay, and we need the reference to texture rect. So I will give that unique name. Then I believe this is all good, and we need to export var slot name, which is a string. Let's do ready function. And we will do set equipment texture. Texture rect texture is equal to texture. Okay. So this is enough for now. We can go back to on-screen UI. And in our on-screen UI, we'll get like, I don't know, 4 child scenes of on-screen equipment slot. 2, 3, 4. Okay. So the slot name, and let's name this properly, that's going to be right hand slot, left hand slot. Let's do potion slot, and let's do spell slot. Let's name those accordingly. So right hand, left hand, potion, and spell. Okay, I don't believe anything else is needed. Let me see how this looks. Pretty good, but we need to clear that one. Okay. Yeah. And now we are ready to work on our script. On-screen UI. Last name. On-screen UI. And let's get the references to all of the slots, and we can give unique names. Okay, now this looks way better. Perfect. And let's create slots dictionary. So we know what type of equipment matches to what. And at the beginning, I can hide the spell slot since we don't have the spells from the very beginning. We'll handle casting some simple spells in future sections. So here we have right hand, right? And if you don't know where those values come from, let's go back to our inventory item. And here we have the definitions for the slots. Right hand, left hand, potions. So that's what we're working here with. So right hand should go to right slot. Left hand should go to left slot. And the potions, is that correct? Potions, yes, potions. Should go to potion slot. With that, we can just create a simple function called equip item. Item, inventory item, and slot to equip is a string, and I will just do slot dictionary get slot to equip set what is wrong, right slot, right hand slot, fair, left hand slot, just some typos, set equipment texture item texture. So basically we'll call that function with information about which slot we would like to use to equip given item, and by that, using our dictionary, we get the reference to proper equipment slot, and we just call set equipment texture with given item texture. So the one thing now to do is go back to inventory, and when we equip things, we need to connect on-screen UI to inventory. So here I will do instantiate on-screen UI. I will, here in our inventory, I will get the reference to on-screen UI. Okay, and here on item being equipped, I will just call on screen UI equip item, and this is item to equip with slot to equip, which of course should be a string. Okay, and if I did everything correctly, if I pick up my sword and I click on it, and okay, I know why I can't click on it. This is because our on-screen UI is right now overlaying the inventory UI. This is due to the fact that the nodes, subnodes of a given scene are rendered from top to bottom. So to prevent that, I just need to move on-screen UI above inventory UI. There are other ways to do it, but this is the simplest. Okay, so now I can click equipped right hand, and it crashes and burns. Let's see, non-existent function, set equipment texture in base new. Let's see, right hand. right hand slot. Is this correct? It's the same. Okay, but why? Okay, so the problem is that for some reason right hand slot has all references set to null. This is due to the fact how the scenes are being instantiated when Godot runs your game. We can prevent that by just saying also make it on ready. So yeah, like fill it out when on the scene is getting ready. And now I can equip it and no crash, but also nothing in the right hand. So this is not perfect. Let's figure out what is going on. So I know that this is getting called. Okay, so the slot to equip is right hand. The item has a texture. Okay, so we need to go to on-screen equipment slot and check what is going on here. We have texture rect, which is empty, and the texture itself, it does reference the sprite. So why it does not show here? Let's go to remote player, on-screen UI, margin container, hbox, right hand slot. The slot name is empty though. Let's see. Right hand, left hand, and spell. I think I know what is happening. If you go to 2D and texture rect, you can see that basically it has no size, right? So if I bump it up to custom minimum size of 1440 and now try to do this, yeah, you can see that we have our sword in our on-screen UI, which is perfect. And then the next step for us is to actually implement combat animations and combat system. So we'll do that in the next section. It's time to start working on our combat system. So first thing that I'm going to do is to add the ability to actually perform left or right hand action. So going to project input map, I will create new action. Let me just improve that a little bit. So I'm not going to call this attack because, for example, you might have, I don't know, a spell book or a shield in your left hand. So let's call this just action. So for simplicity's sake, and you can improve this however you want, let's say that left hand action and right hand action. For simplicity's sake, the left hand action will be performed with an L and right hand action with R, right? And this is just for testing purposes. The controls can be improved as you wish. Okay, so we have that. Let's close it now. Going to our player, we really need to set it up properly. So the combat system is actually going to be a little bit more complex. So I'm going to add a child node, and it's going to be node 2D. We'll call this combat system, and I will make sure that this is placed correctly. It should be in 0, 0. This is correct, and we will actually need to give it a little bit of children. So we'll do sprite 2D, and I will call this right hand, let's call this weapon sprite, and let's see the position for that. Do I care about it? No, not really. But I will add area 2D to it, and I will add collision shape. All right, so this set of nodes will represent the weapon that we have in our hands. So the sprite and then the collision. Now to make it work, we need to go to our layer names, to the physics, and we'll add another 2 layers. So the 5 will be weapon, and the 6 will be, enemy. With that information set up, I can go to all my collision and say that it exists on layer 5 and it hits layer 6. Okay, so the weapon layer hits enemy layer, nothing else. Okay, and basically I could just duplicate this and call this left hand weapon right. And this, of course, could be moved to a separate scene just to keep a tree more clear. Okay, we have all of that set up. So I think it's time to start writing our combat system script. Let's go to scripts. Let's get rid of this. So class name is combat system, and we will need reference to animated sprite 2D, which is fine. But then I believe we also need to set up our combat animations. So going to our animated sprite 2D, I will add some simple frames, and this is going to be back attack. We need front attack, left attack, and the right. And they should all come from the sprite sheet. So starting with the back, where is it? White fighter. Okay, set this to 7. Zoom in. So these ones look like he's attacking because he has his hand extended. Right, so this would be back attack. Front attack is going to be this one. Left attack is that one. Oh, I don't want 2 frames. Okay, just this one. And right attack, that. Okay, perfect. So we have that set up, and this also requires the app to implement more stuff when it comes to animations. So we have play movement, play idle animation, which is good. Then we need to set up the direction to attack animation and direction to attack vector. So let's do direction to attack animation. And again, this all could be handled with the animation tree, but since this is so simple when it comes to transition, we do it by hand. Front attack, right is right attack. And now as I'm writing this, maybe we don't even need this because we can translate the key to a value very easily by just attaching underscore attack, but let's leave it as it is. And what is more important, we need direction to attack vector. Okay, and this is again back to vector 2, 0 minus 1, front to vector 2, 0, 1, right to vector 2, 1, 0, and left to vector 2, minus 1, 0. Okay, vector 2, of course. And then we need to store the attack direction, which starts as null. Okay. Let's see, we will create a function to do play attack animation, and then we can do this. Var direction is equal to animation split, and take the first one. Attack direction is equal to direction, and then play. We could do just basically we could do attack direction plus attack, right? And then we don't really need this one, which is perfect. Oh no, we will need it, and we will need it later. Okay, so we can just do it the good old way. So direction to attack animation, direction, and it is going to work. All right, so far so good when it comes to playing this animation. We can test this by going to player. And actually, I believe that yeah, we can do it in combat system. So here I will just handle the input in event. And if input is action just pressed, right hand action. If input is action just pressed, left hand action. Okay, and I will do just animate the sprite 2D, play attack animation, and then I will do animate the sprite 2D. Here also play attack animation. Okay. Let's see whether this works. So I'm here, I press L, okay, but it loops, which is not great, and R, and right, and now it goes crazy. Okay. So first thing, a few things that we need to clear. So going to sprite frames, the attack animations, they shouldn't really loop. This is front, so we need to get rid of that. Not the animation, but the frame. Okay. Try it again. Right. The animation is going to be the same. The problem is that it does not return back to the idle after attack. So going here to our animation controller. Okay, we need to listen for animation finished. So animation finished. Connect here on animation finished. Where is it? Here. So we need to check whether we finished the attack animation. So if direction to attack animation values has animation, it means that the attack animation has just finished, and we need to get information about what the animation, what the direction of the animation was. So direction is going to be direction to attack animation 5t of animation string, and then we just play direction and idle, and we do attack direction is equal to no. Okay, so let's try this. Yeah, now as you can see, it goes back to idle properly. Okay, so this more than working on the whole combat system was the setup of the attack animations for our player. In the next section, we will continue working on our combat system and working on displaying the weapon. See you there. Okay, so with animations for attack in place, right, we can finally add the ability to equip the weapon to our combat system. So again, this goes through the inventory system. So going to inventory, we have that, but we also need the reference to combat system, which we now have. And then in our, let's see, in our inventory system, we will create a function called set active weapon. So combat system, set active weapon, item to equip weapon item, and slot to equip. So now going back to our combat system, we need to get the active weapon here. So func set active weapon. Weapon is of type weapon item, and slot to equip is a string. We could make it an enum, but string is fine. So we have two cases: left hand, and we have right hand, of course. and they are pretty similar but have some differences. So what we need is more references here. We need a right hand weapon sprite, a left hand weapon sprite, and we need a right hand collision shape 2D and left hand collision shape 2D. Sorry. Yes, why does it scream at me? Has the same name. Oh, of course, this is right hand collision shape 2D, and this is of course left hand collision shape 2D. Okay, and now we are able to set the active weapon. So for the left hand, there's a possibility that the collision shape is null. Well, this is case for both actually, because for example, you could equip a shield or I don't know, spellbook that isn't like a melee attack, right? So let's check for collision shape. Let's do left hand collision shape is equal to weapon collision shape, and then left hand weapon sprite texture is equal to weapon in hand texture. And we also need to keep track of our left and right weapon. You can simply do export right weapon, and that actually is going to allow us to assign the weapon in other way than just via inventory. Okay, so now I can say left weapon is equal to weapon, and pretty much the same goes for the right hand weapon. So if weapon collision shape is not equal to null, this is of course in hand texture, and right weapon is equal to weapon. Okay, this has nothing to do with the visibility of that on screen as of yet, but I can go grab the weapon, equip it to the right hand. If I go to remote player combat system right hand, I can see that it actually has a texture now, which is wonderful. Okay, then we need to go back to the attacking. And set this up. So we have can attack, because I want to be able to prevent the button spam. You know, we need to wait for the animation to finish, so we don't just spam attack all the time. And I can do this with ready function and saying animate the sprite to D, and we will get the custom signal here called attack animation finished. And what we will do is we'll probably emit this on every single finish here. So oops, that's what I wanted. So every time we finish an attack, we'll emit this, and then our combat system will know that we can attack again. So attack animation finished, connect on attack animation finished. We of course have to define this. This is going to be a very simple function. Can attack is set to true. Okay. And then let's see, these are attack actions and they are pretty much the same. So we will see what can we improve here when it comes to code readability, but let's start with right hand action. If you cannot attack right now, we return, and then can attack, put to false. This is just to you know, prevent the attack spam. Then we play the animation. Then we need to get the attack direction, and this is animation sprite d attack direction. We check whether we have weapon equipped, and if we do, let's just return. Then we get the attack data. So, and as you may remember, this is in our weapon item, right? Our attack data, so the attachment position, rotation, and set index for each weapon. So we do right weapon, get data for direction, and we do attack direction. And here comes one important part that we need to set up. So I believe that at the very start, we need to actually disable the collision ship, or do we? We'll see. So yeah, we'll need to disable it at the start of any attack, but that does not matter right now. Okay, so we have the attack data, and we can start assigning this to the sprite. So right hand sprite position is equal to attack data get attachment position. Then right hand weapon sprite rotation in degrees is equal to attack data get rotation, and then right hand weapon sprite z index is equal to attack data get z index. Okay, I believe that's all. Let's see how that works, and if it works at all. So I grab this, I equip it to right hand, hide this, and you can see, okay, yeah, that's one problem. You can see it's not getting hidden, and it's not in the right place at the start. So we need to improve it a little bit, but it's good, it's good. Okay, so on attack animation finished, what we need to do is we need to hide the sprites. Okay, and when we start this, we need to show the sprite. Okay, let's see how this improves our situation. Okay, so this looks almost good. I just screw up the rotation and the position for the sword for the top attack. So let's see what's wrong with that. This can be found in our sword weapon item. And this is a problem with the attachment and the rotation. So let me try and find the proper values for that. Okay, this is minus 13.4, 13.4, 5 and 10, minus 5, minus 11. 90 minus 90, 0, minus 180. Let's try this again. And now it works. Perfect. The one problem though, it is visible at the start. I don't want this, so hide this and hide this. Okay. So I'm picking it up, equipping it, and now I can attack in all directions. Perfect. And you can see I have to wait for the animation to finish to be able to attack again. So now it's probably good time to set up something for a left hand to see whether this will work. So we will set up a shield, because that completes our classical knight adventure. So get rid of that and go into resources, weapons, create new folder, shield, and with everything that we've done so far, you will see how easy it is to set up new weapons. So what I am doing is I'll create new resource, call this shield. I'm working with resource. Now I will call this shield inventory item. I will load the inventory item script here. This is equipable to left hand. We need to figure out the ground collision shape for that. And that's not a problem, because we can go to our pickup item. I can find a shield here. I can drop it to the sprite, to D. And then I can do new rectangle shape. Make a collision shape for that. Then save as. Go to shield. Call this shield ground collision shape. Go back to a shield. Grab the collision shape, call this a shield. I will provide a texture here, which is of course a shield. I don't think we need side texture. Max stack is 1. Let's say the price is, I don't know, 65. And we can move to creating the weapon item resource. Resources are wonderful. I love resources. It's going to be shield weapon item. Load the weapon item script. So now we have in-hand texture and then side in-hand texture, which will be important because it would be stupid to display the shield, you know, like from I don't know, from with the front face when we're fighting, when we are facing sideways. Attack type doesn't really matter, but we can change it to melee. Do we need collision shape for a shield? Not really. I do not plan to add the blocking mechanism. Oops, sorry. To add the blocking mechanism to the game, but something that you might want to add. Let me just write that real quick. Okay, so we have that. Then let's go to other stuff that we need, which is the attachment position, rotation, and index. Okay, so attachment position, this is -13 and 2, 14 and 2, 0 and 10, 0 and -10. Rotation is 180, 0, 0, and we have front as 1. Okay, so this is our shield configured, and I can just say that in my inventory item, the weapon item is the shield, right? And it equips to left hand. We stop this. Going back to a main, I can just grab, this is gold, I can swap the gold to represent, let me do a quick load to do a shield. It doesn't change, we could write a script that does change it to a proper texture, which would be cool actually. Let me write that down. That would be really cool and really useful. Okay. So now if we play the game, I can see that I have a sword, I have a shield, and I click equip to right hand and equip to left hand, and they're equipped in the proper slots, and then I can handle the left hand in my combat system. So going to script, going to combat system, and trying to handle the left hand. So if you cannot attack, we will return, and as I can see, this is all pretty similar, right? So I can just write a function called perform action. What do we need here? Let's see. Not that much, because the one thing that is different is right weapon, and this is weapon item. Okay, so we need weapon item, or just no weapon, and we need the sprite. So this is going to be sprite, which is of type sprite 2D. And then looking at this, I can just copy all of this and say, okay, so this is correct. Here we check for weapon, Okay, and then we check for sprite. And then instead of all of this, I can just write perform action. This is right weapon. And we need a sprite, which is right hand weapon sprite. And then here, I can write the same. Perform action, left hand weapon sprite. Sorry, left weapon, left hand weapon sprite. Okay. Is this enough to handle both the shield and the sword? So let's say this is R and this is L. Well, the one problem is that we would like to display that side texture here. So we need to improve this a little bit. Let's see. Where do we assign the texture? So in our perform action, we assign the texture here just once, which might be a little wrong, but don't worry, we can improve this. So first we need to check if weapon side in hand texture is not equal to null, right? And we need to check whether attack direction is equal to left or right. So we can just write something like left, right, and this is an array of string, and then I can do includes has. I can do has attack direction, and we can then switch the sprite texture to be sprite texture weapon side in hand texture. Else we do sprite texture and we do weapon in hand texture. Okay, and with that we should be able to, when it comes to our shield, display different thing. Okay, yeah, now we're displaying different texture, as you can see. But other than that, it stopped working. Let me see. Pick it up, equip it. Okay, nothing there. Okay. Oh, this is because, let me see, on attack finish, right hand weapon sprite, left hand weapon sprite. We should be hiding this. And I know where the problem is coming from, because, and it's not only for the shield. Let me equip a sword here, and let's attack. And if I press attack and in the middle of the animation I start walking, you can see that the sprite is not getting hidden. It's an easy fix, and this is how I believe it's handled in Zelda. So go to a player where we control the movement, and we have a reference to animate the sprite 2D here, and we'll prevent the movement if animation, currently running animation, is some kind of attack animation. So you cannot like walk and attack at the very same time. Okay, so let's try this. Yeah, and I have to choose either I attack or I walk, and I can display a shield as I'm blocking. Perfect. So we have our shielding and our attacking setup. I believe the next thing to handle is actually dropping items, because we have option to drop it. We have to implement it yet. So see you in the next section. Okay, so in this section, we'll handle dropping the items back on the ground. So we need to start from the very bottom, which is our inventory slot script. So here, we'll do two things. First, we'll add a signal. We'll call this signal drop item. And we will emit drop item signal. But also what we need to do is to do main button disabled true, because we don't want somebody to open the menu, drop item, and then do anything else with it, right? Like trying to click it, because this item should be considered dropped from the inventory. So we're just emitting the signal, and inventory slot is going to be handled here in our inventory UI. So let's go to that script, and here, similarly to what we did with the equip item, we will add another function. So inventory slot drop item from connect. Let's create inline function. So we'll just call drop item on the ground, emit I. So we need that I to know which item is getting dropped. And this is going to be another signal. This is going to be handled in inventory system. Drop item on the ground, and we pass index of the item. Right, so this signal now is getting emitted, and this is going to be handled in inventory. So let's see. Inventory UI, drop item on the ground, connect, and we will call this drop item or on item dropped. So let's write that function. We need to do two things here. Oops. This is function on item dropped. IDX will need to clear inventory slot under the index IDX and eject item into the ground IDX. So we need those two functions. Clear, let's maybe comment this one for now. Clear inventory slot. We need to track how how many slots in inventory are taken. So let's add that variable here. Taken inventory slots count. We start with 0. And then as we add an item, here we do taken inventory slots count plus equals 1. And in our stackable item, whenever we add an item, we add 1, and also here we need to add 1. Okay, so first in clear inventory slot, we will do taken inventory slots count, so this equals 1. And then we need to do idx int here. And then from here we do player, or sorry, inventory UI clear slot at index idx. So we're going back down to inventory UI, and we write clear slot at index function. Okay, so clear slot at index, right? So let me just maybe show that to you. We have our inventory with our grid. We drop item, and we need to have that slot cleared and prepared to be able to add new item to it in case we pick it up. And also we need to pop an item from our inventory back to the ground, back like in our main scene. So handling the clearing slot, we need to get new clear slot. Clear inventory slot, so or maybe like empty. It's a better name. Inventory slot is inventory slot scene. Instantiate, and we need that this is inventory slot. Then we go call toggle, which will basically hide our inventory UI. So after dropping an item to the ground, we close the UI. And then we need to connect everything back. So drop item, connect. We have, for this new inventory slot we are creating, we need to reconnect everything. Just like we did here, right? This is when we have clear, just like we have when we have here. So here we create the initial empty inventory slots, and here we're creating another empty inventory slot and we're replacing the old one. Empty inventory slot, equip item, connect. Okay. Then we find the child tile to remove from the read container. The remove child and we first add new inventory slot. Sorry, empty inventory slot. And then what we also do is we move tile, right? And this allows us to move that new inventory slot in the proper place in our grid container. So we get that clear, empty inventory slot, and we move it to IDX. Okay, let's see where that works. I grab this and I click and drop, and it's no longer there, right? But you can see it working properly if I grab both. I drop this and the shield is still in place. So the second part of it is to actually drop that item onto the ground. Okay. So going back to our inventory, we need to write eject item into the ground function. Okay, so this is going to be a little bit more complex, but we can handle this step by step as always. Function eject item into the ground, IDX ENT. Let's first find what inventory item we'd like to eject inventory item to eject items IDX. Then we need to instantiate it back as a pickup item. Item to eject as pickup, because we need to create this. So this is item scene. Oh, what's your problem? Mixed use of tabs and spaces. Okay. Okay. We need to have that item scene so that we can recreate the item. So we need to find this pickup item scene. Let's grab this. Okay. So we can just say should be pickup item scene. Pickup item scene, instantiate as pickup item, because if we drop the item, I want to be able to pick it up again. So item to eject as pickup inventory item is equal to inventory item to eject. Item to eject as pickup stacks is equal to inventory item to eject stacks. Then we need to add it. So get 3 root add child item to eject as pickup. We need to disable collision for that item. So we'll write a helper function here. And this is due to the fact that while ejecting, I don't want it to collide, I don't know, with any kind of obstacles. So going to inventory slot, pickup item. I'll write few simple functions, actually 2. Disable collision, and of course enable collision. Okay, with that in place, I can go back to our what is it? Inventory, of course. Okay, so we do, because I don't want to actually just only, let me get this sorted. So when we eject, if this is our player and he's ejecting, I don't know, some kind of item, I actually want not to spawn it in the place of our player, but just like throw it a little bit, you know, like it's being actually ejected, shoved out of my inventory. For that we need more setup. So item to eject as pickup, I can call disable collision. Item to eject as pickup, global position is equal to get parent global position, so it will start in the position of my player, and I have to disable the collision so it does not collide with the player, because then it would automatically get added back to my inventory. And then I need to calculate where it should be dropped, right? So to do that, I will need the reference to let's open our inventory. I need the reference to my animated sprite, because the animated sprite knows in which direction the player is facing. Okay, and in it I will calculate direction to eject the item. So item eject direction by default is going to be down, but then as we are moving we will be changing it. So item eject direction is vector to right. Item eject direction here is vector to left. Item eject direction, this is vector to down, and this one is item eject direction is vector to up. Perfect. Going back to my inventory, I can use that to get the eject direction as I made the spray to the item eject direction. And then we need to actually eject it in a kind of random direction. So if eject direction x is equal to 0, we need to do eject direction x is randf from range of -1 to 1, else drop eject direction y. We'll randomize this a little bit from -1 to 1. Let's see. Eject direction expected closing after call arguments. eject direction. Oh, I missed the comma. Okay. Okay, then I also want to have that animated. So we'll use a twin. So let's find eject position. This is get parent, global position. Use vector will do 2020 times eject direction. So it will randomize us closely, like when we're dropping, we'll find a point around the sphere on our user and drop an item there, but we're taking into consideration the direction in which user is facing. So if he's facing left, we'll search that point roughly here. If he's facing up, we'll search here. If he's searching right, we'll do here. And if he's facing down, we'll search for that drop point here. Okay, and now we need to twin. For ejection twin is get create twin. Ejection twin set trans twin transbounce. That does rhyme. Ejection twin property of item to eject as pickup will transform twin the global position into eject position with 0.2 as a duration, so it's going to be quick. And when the ejection twin is finished, we need to re-enable the collision. Enable collision. And why do we do it this way? Again, with enabling and disabling the collision. This is because when we start the ejection, we would like to show that it is getting ejected from a player position, right? So item that we eject goes from here to here. The problem is, for the duration, for part of the duration of the twin, its collision box overlaps, of course, with the player collision box. And we wrote a code that says, hey, whenever this pickup item overlaps with the player, it should be added to inventory. So we need to disable that to be able to throw it out of our player and then re-enable collision so the player can pick it up again. Okay? And of course, if we remove it from inventory, we also need to remove it from our combat system. So combat system, right weapon is equal to inventory item to eject. Weapon item, we do combat system right weapon is equal to null, and on screen UI right hand slot set equipment texture to null. And then we need to do the same for left weapon. Inventory item to eject, weapon item, combat system, left weapon, set it to null. On screen UI, left hand slot, set equipment texture to null. And then we need to set items under IDX to null. So we need to wipe out the information of that weapon. And that actually changes a little bit our logic when adding the item, because what we had was an array of items in inventory. And remember that this array corresponds directly to inventory slots. So when we remove one of the items from items array, we cannot change the size of that array, right? So like just compress it to be smaller, because those indexes in array correspond to the inventory slots. So instead we have to make the dropped item a null in our array, so that we know that, okay, this is null, so the inventory slot is empty. And that's what we do right here. But this changes one logic a little bit when we do add items to our inventory. So we need to find the IDX we need to find first, we need to search for first empty slot in our items array. So items, we search for empty in our array, and if we have empty slot, so IDX is not equal to -1, we do items of IDX item, else if we do not have any empty slots, we just do standard append, right? Okay, that was a whole lot of code. Let's see whether this actually works. We have two items, I drop it, and enable collision inventory item to eject. Let's see, it should be item to eject as pickup, of course. Okay, so I just pick it up, I drop it, and I can pick it up again, and I can drop it. And if I go to that, this goes now into first slot, this goes into second slot, drop it. Okay, I can drop that, and now we have empty slot in the middle. I pick it up, it goes in the middle, and it freaking works. This is brilliant. So now we have an inventory where we can drop items. So that was a lot. Let me think about the next section. I believe we could take a look at spells and spellcasting. Yeah, we do that, and then we will go to health system and enemies. So yeah, there's still a few episodes, sections left for me to record. See you in the next one. Okay, so in this section we will start working on our spellcasting system, and to do that we will need a weapon, which is going to be a spellbook. So going to our resources and weapons, I will create new folder for the spellbook, and I'll create new resource. I'll call this spell. Oh, sorry, it's, of course, it's a resource, and it's going to be spell book inventory. item. When we go to assets and search for book, there's the one that we are going to use. So here, let's attach a script. It's going to be inventory item. Slot type, this is going to be, for example, left hand. This is going to be spell book. The texture is here. Max tax 1, price to 120. And we need ground collision shape. Again, this is the same as before. Just go to our pickup item. We change the sprite to represent this. Go to 2D. When it comes to collision shape, let's create a new one. Okay, and let's save this. And going to resources, weapons, spellbook, we do spell book ground collision item. Perfect. Going back to our spellbook item, ground collision shape is here. And now it's time to create the weapon item for a spellbook. So resource, call this spellbook weapon item. Okay. Let's see what values do we need here. So in hand texture, of course. Oh, we need to assign the script first. So this is going to be weapon item. In hand texture, it's going to be sprite in hand. Collision shape none. Damage attack type magic. We'll also need to add damage later. And then the values for rotation, Z index, and attachment position. So we do -11 and 2, 11 and 2, 0 and 11, 0 and -10. Rotation is -90, 90, 180, and 0. And the indexes are all 0. And then I can pass this here and go into our main, changing one of the pickup items to be spellbook inventory item. And let's see how this works. So pick this up, I can equip it to a left hand, and if I perform my left hand action, I actually can cast a spell. Okay, but this gets more complex than that, because I would like to define few spells and make our user able to actually cast a spell. So how do we do that? We need to start with our inventory system. Let's see, or either with our, well, there's a lot actually. You know what, we will start by actually doing the spell configuration. So here I will add another folder. I'll call this spells, and I will create a spell configuration script. Going to scripts, create new script. I'll call this spell config. And let's open it up. Get rid of that, and we'll do a resource. It's going to be a class name, and we do export speed of 10, export collision shape, which is going to be rectangle shape, we will do spell name, we will do initial rotation, we'll do UI texture, we will do initial cooldown, and we will do damage, and also assign 10. Okay, so how, oh, this should be of course spell config. Let's see how we can make it work based on our assets. So going to scroll, we have some scroll here, right? That will represent a given spell. And then I believe in FX magic, we have sprite sheet for, or is it in particle? Yeah, we have some particles that may represent a spell. For example, I don't know, we have rock here, we have fire, or is it in projectile? Oh yeah, we have fireball here, we have energy ball, cannonball, so different like projectiles that we can use. Okay, so then we have the spell configuration, and we need to create our spells. So we will do a spell scene. Let's see. It doesn't need too much, so we can do area 2D. Call this a spell. Save it in our scenes. It will need animated sprite 2D, and it will need a collision shape. Okay, we'll create a new set of sprites, and we'll add them one by one. We'll handle three spells here: fireball, oops, the fireball, the ice, and the, I don't know, plant, I call it. And then we'll set this to 10 frames per second, and we will go to search for them for sprite sheet frames. Because maybe, let me think, we have the projectile. Can I just grab the fireball and put, yeah, and it's not gonna work like that because it treats it as a singular sprite. I don't want to remove this, I want to remove that. So add frames from sprite sheet, and let's search for that. It's going to be in assets, fx projectile. Let's find the fireball, and this is 1x4, or sorry, yeah, this should be 1, oh no, 4x1, of course. Okay, and we will select all the frames and add them, go to 2D and play this now. We'll see we have nice fireball. Then going to ice, we go ice spike. This has more, this is like 1 by 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, 8 by 1. Okay, select them all. Come on. Okay. And then for a, oh, this should be, limit. This is fireball, and then there, that one is a plant. And we can find a plant spike, and this is again 4x1. Grab all of those, and we have the animations set up, and it has to be faster than that. This is 10. This should also be 10 FPS, and this one should also be 10 FPS. Cool. This looks good. So for the collision shape, for each one we need to figure out the proper collision shape. So let's do this. We'll save those. Let's see, we have resources, spells, and I will create a new folder here. This is going to be fireball. Then we have ice, and then we have plant. Okay, for each we will create a collision shape, starting with the plant. Let's see, new rectangle collision shape, and I believe that doing 24x19 is good enough. So let's save this as, let's go to resources, spells, plant, and this is going to be plant collision shape. Then going to animation, switching to ice. We can now create new collision shape, new rectangle shape. Let me see, for ice I have 13x14. Well, let's do it more like that. So this is 17x8. Save it. Let's go to resources, spells, ice, and this is ice collision shape. And then for our fireball, we also do new rectangle shape and something like this is good, I believe. So let's save as fireball collision shape. Okay, and we can actually write the spell script here. It's going to be rather simple. Get rid of everything. Oh, distraction free mode. Let's check this out. Nice. Nice. I like it. Okay. Control Shift F11. You learn something every day. Okay. So class name is spell. And then we have two already things that we need, which is of course the collision shape and the animated sprite 2D. And I can say direction is vector2, speed is float, damage is int. And we do init function here instead of ready. We'll pass here the spell config. And then I can say collision shape 2D, shape is equal to config, collision shape. Damage is equal to config damage. Name is equal to config spell name. Speed is equal to config speed. And animated sprite 2D, play config spell name. Oh, this is so incorrect. Okay, and then function process position is equal to please equals speed times delta times direction. Perfect. So this is our spell scene setup, and we also have a spell book setup. So the next part to do is actually to cast the spells, which we'll do in the next section. Okay, so in this section, we'll try to handle the UI for spell slots. So the spell slots should be visible and active only when you have some kind of magic item equipped, like a spell book, or I don't know, magic wand, something like that. So let's go to our inventory UI. And let's actually add the spells UI below the grid container. So I'm gonna make it as a VBox container. So let's add a VBox container, and I'm going to call this spells UI. And again, this could be moved to a separate scene. You can make it as granular as needed. We'll add a label, spells label. Let's call this spells center and center. Add the theme to set the font. Do we need any font variations? Well, we want to have a theme color and font size I will set to 26. So we can see how it looks already. And then I will do HBox container to fit all of our spells, and I will add inventory slots, and I will make them, how many did we define? I believe we defined 3, right? So keep this in the center, and in the center 1, 2, 3 spells, and we have fire spell slot, and we have ice spell slot, and then we have plant spell slot, right? Perfect. Okay, we can provide the starting texture here, and this is very nice because that's what we need. So this is going to be in items, scroll fire. We'll make this sorry. Oh, let me bring my microphone back up. And this is the reason why we made it a single press. Okay, so because we only click on it once, it doesn't have the drop down. So how does it work? Or how will it work? We'll have 3 spell slots that are only visible if above you equipped a magic item is equipped. Okay, and then you can click on fire, ice, or plant to choose it as your active spell that your character then will cast. So we have that start label is going to be fire. Sorry, that's the wrong one. So this one, fire, single press button, fire. Then we have ice, which is scroll ice, and then we have, and this is ice, and then we have a plant, which should have that one, and call this plant. Perfect. So we have those, and then we basically have to go here and handle the single button press. So let's see, do we have that set up? I believe we don't. Okay, that's going to be rather simple. So we just go to this one and we just do pressed, on click button pressed in inventory slot. Okay, and what we do here is we just say we'll use another signal here, slot clicked. Okay, we do slot clicked, emit, and we'll of course set it up in our inventory UI. So in our inventory UI, what we will do is we will get the reference to all of our slots, and we can do it like already. Spell slots is an array of inventory slots, and we can say that this is fire. Oops, let's give them unique names because the path is too long. Okay, and we just drag those 1, 2, and 3. And now we have an array of references to those slots, to those scenes. Okay, and then in onReady, we actually have to set up the listeners for our signal. So for I, in spells slots size, we do spell slots at I, slot clicked, connect to on spell slot clicked, and we'll write that function and bind the I argument there. So this is alternative to actually this is the alternative version of just writing a function here. You can create a function as an inline function by just binding an argument. Okay, so let's see, on spell slot clicked, on spell slot clicked, we do I, emit int, and then I can just say spell slot clicked emit I, so we have to re-emit that signal. Signal spell slot clicked emit, oh sorry, it will take idx as int. Okay, so this is all good. This is of course getting handled in inventory. So inventory system, and we have to write the function that will be triggered when the spell slot is clicked. So in inventory, let me collapse all of that. Oops, let me collapse it. Okay, and I can write spell slot clicked idx. We need to track the selected spell slot, so let's grab a variable here, selected spell index is -1 at the start, and then selected spell index is IDX. And then we need to do a little bit more. So we need to call player inventory UI set selected spell slot as selected spell index. Let's go to inventory UI and let's write this function. Set selected spell slot, and it's gonna get IDX as an int. And what is that function for? So whenever we select one of the spells and deselect the other, I want to have a border for our inventory slot. So I would like to somehow differentiate that this spell is currently selected. Okay, and we can do this by saying for, oops, let me pull this up, for I in spells, where do you have it? Oh, this is an inventory UI. This is inventory UI. And the name that we set select a spell slot. Let's copy this. Set selected spell slot. IDX is int. And as you can see, sometimes I do I, sometimes I do IDX. Doesn't really matter. So for all slots, for I in spell slots size, we need to either remove the border or add the visual border. So spell slots at I, toggle button selected variation. And if you don't know, variation are like different classes in CSS that let you have the very same element look differently. They're kind of annoying to set up, but we can do it nevertheless. So going to inventory slot, let's do inventory slot, and I can just say toggle button selected variation is selected. On click button in type variation is equal to selected if is selected, else set to empty string. Now the one thing that we need to do is to set up the variation on our button. So stick with me, as this is not so intuitive and I wish it would have been handled better in Godot. Okay, so what do we need is, let's see, in our theme, we'll create new theme, open it up. Let's move this around a little bit. And then we need some style boxes and some properties. And I hope I can remember how to do it. So we need to do plus button and then leave everything as default, right? And then we need to add another one, which is going to be like empty. So custom type, we call this selected. And now we have button and selected. And for selected, base type, it has to be button. Okay, and now we have selected here. And then for styles, we search for normal and we add new style box flat. You can open it up, and what we do is we remove the background color, so set it to 0 here, and we go to border and border width. Let's set this to 2, and we choose a color, so like nice red. Okay, so this is our selected style. Yeah, and so we have that set up. We can go back to our button. And now we have selected variation here. So let's see whether this works and whether clicking on it will set that variation with that style on our button and adding its border. So I have that, I have some spells, and when I click it, nothing really happens. Okay. Let's see whether this function gets triggered at all. It doesn't. Okay. We need to figure out why. Toggle button selected variation. So does it trigger? No, I probably forgot to call something, right? So go into our inventory UI. On spell slots clicked. That should trigger. And it does, okay. So what we know is that we can go to inventory. So this should be triggered. And it does not. Spell slot clicked. We do not use it. Okay. So we do not listen to for this. So spell slot click. Connect to on. It should be on spell slot click just to keep it in line with others. So change that. Let's try this again. And as you can see, it has a border. The problem with it right now is that if it's not selected, it's grayed out a little bit. Maybe we want to leave it as that. Yeah, I guess it's fine with leaving it grayed out as it looks totally different than the one that is selected. So this is how we can select our spells. But there's one problem that we need to fix. If I open it now, even though I do not have a book equipped, I can see the spells and I can select those. This is not correct. So going to our inventory UI here, there will be some changes and the spells UI will be disabled at the start, so it's not visible. Okay. And then going to our combat system, not our combat system, to our inventory system. On item equipped is what interests us, because here I can write a function called check magic UI visibility. And we will decide in that function whether to show or hide the spell's UI. So check magic UI visibility should show magic UI, and I will say let me think, if this is gonna be a big if, let's do combat system left weapon is not equal to null, and combat system left weapon attack type is equal to magic, or, and this is getting pretty long as you can see, so what we need to do actually is to break the line I should be able to just say and combat 6, yeah, and then do the same, or we can even make it maybe better. Let's do something like this. Expected new line. There is a new line. Okay, so do a multi-line line in GScript with the backslash, or let's do combat system right weapon is not equal to null, and new line combat system right weapon attack type is equal to magic. So do we wield any magic weapon right now? That is the question. And player inventory UI toggle spells UI based on should show magic UI, and if should show magic UI is equal to false, then we have to handle spell slot. We need to disable it, right? So we will just print disable on screen UI slot for now, and I will leave a to-do comment to do disable spell slot in on screen UI. Okay, we need to write a toggle spells UI function. This is going to be real simple. So function toggle spells UI is visible boolean. We need a reference to spells UI. So let's grab this, let's give it unique access name. And then I can say spells UI visible is equal to is visible. Okay, so this is almost everything we need for our spell UI. So I pick up the book. It's not, we don't see the spells UI, but if I do equip to left hand, it still doesn't work because we need to check the visibility when equipping stuff. So going back to inventory, we have check magic UI visibility, and it is getting triggered on item dropped, and we need to also check it here on item equipped. Let's see. Now I am able to select this, right? And if I drop the only magic item that I have equipped, you can see it's no longer there. So this is the setup for our spells UI. I believe it's still not complete. There's some to do, but we'll handle this in the next section when we will be finally able to cast it. So I'll see you there. Okay, so moving this along, in our on-screen UI, you can see that we have defined the spell slot for the spells, right? We just need to trigger it and make it visible with the correct spell selected. So going to our this on-screen UI, let's see, on-screen UI, I will write a simple script. That's gonna be toggle spell slot, which is visible, is visible as an argument, and UI texture as a texture. You can just say spell slot visible is equal to is visible, and then if it is visible, we say spell slot set equipment texture set it to UI texture. Okay, so this goes back to our inventory system. When we do this has to be disabled. So here I can say on-screen UI toggle spell slot visible false, UI texture we can pass null. All right, so this is the case where we disable it. Then we need a case where we toggle this back on. And activating that and handling the spell casting and stuff like that, we will handle in a separate system. So going back to our player, let's go to our player here. Let's collapse this. I'll add another empty node, and I will call this spell system. Let's attach a script. Go to scripts and open it up. Just an empty node. And let's start hacking away. Okay, so we need our class name, spell system, then we'll do spell configs. So this is going to be an array of can we do it actually as array of spell config, okay, and we'll just preload everything that we need, which is fire. We have, oh, do we have those configurations defined? Let's see. Resources, spells, no. Okay, so create new resource. This is gonna be fire spell config. Let's add a script here. So this is spell configuration, and let's start hacking away. So fire spell config, let's set the speed to be 14. Collision shape is fireball collision shape. Spell name is fireball. Initial rotation is set to 90. UI texture is scroll fire. And we have a cooldown for it set to 2 seconds and 15. Okay. And we need that initial rotation here, because if you go to spell, you can see that this is going left. This is pointing left, and this is for any reason pointing right. So we need to rotate it at the very start. Okay, so we have that configuration. Let's create another. Create new resource of type resource, or maybe we can even be smarter. Let's see. Create new resource, and I can choose spell config. Perfect, and I can call this ice spell config. Let's see some values here for you. This might be, I don't know, ice is faster, I don't know why. Ice collision shape, spell name ice cone, anything 0. This uses scroll ice. Initial cooldown, let's set it to 4, and damage to, I don't know, 25. And then for the plant, let's go again. Spell config plant, spell config. Okay. And here we go with, I know, 30. Collision shape is the plant collision shape, which we prepared previously. It's a plant. Initial rotation is 0. UI texture is scroll plant. Cooldown is 3. Damage is, I don't know, like 17 for any reason. Okay, so we have those configurations, and we can go back to our spell system. Okay, and now I can just do preload and search for fire spell config. Then I can do another preload, and this is ice spell config, and then I can do preload, and this is plant spell config. Okay, so we have our array. Then in a spell system, we need actually a reference to animated sprite 2D. We need a reference to spell scene. Where is it? Spell TSCN. Can I click and drag from here? No. Let's see, spell TSCN. Perfect. So this is our spell scene. We need a reference to our inventory. and we need a reference to our on-screen UI. Perfect. And then we need to set up our timer. Current spell cooldown and cooldown timer. And I'm going to set up this timer by hand, but you can also use a timer node. That's fine too. Okay, let's do ready function. The only thing I want to do here is to go to inventory and on spell activated. I need to, let's see, in inventory system. This happens on spell slot clicked. So basically I can connect there. So inventory, spells on spell slot clicked. Well, I cannot connect to this. I need to emit a signal, right? So go to inventory and we'll add another signal here. We have spell slot clicked and we will do let's see, spell activated, emit selected spell index. So let's create that signal. Spell activated, spell index is of type int. And I can go back to my spell system and do spell activated, connect, and we will create a function on, on spell activated. Okay, so on spell activated, we need to store information about active spell. So let's add this var active spell index, started as -1. We set which spell is currently active, so which spell we will be casting, right? Then we will get the proper spell config. So spell config is equal to spell configs at IDX index. And we have reference to on-screen UI. And we will say toggle spell slot through spell config UI texture. And if we did not screw up anything, now if I click on the, if I equip it and click here, now I can see that my spell is activated. And I can see it in on-screen UI. And if I switch to eyes, you can see that this icon is changing here as I'm changing it here. Perfect. And then of course, if I drop it, this gets hidden. I can pick it up again and I can equip it. Perfect. Now, we need to cast a spell finally. So in our spell system, probably we need to go to, let me think. We need to go to our combat system to trigger it. Because when we perform an action, where is it? Here, we need to check if weapon attack type is equal to magic And if it is, we have two options. We can either emit a signal or we can get a system reference. And I will emit a signal. The signal is gonna be cast spell, or maybe cast active spell is better. And we'll do cast active spell emit. And then in my spell system, I need a reference to my combat system. And here I will just say combat system cast active spell on cast active spell, and we'll write that function. So we'll just write function on cast active spell. Okay. So spell direction. This is of course animated sprite to the attack vector. Then spell config is spell configs at active spell configs, yes, at active spell index, cast active spell connect. That's what was missing. Okay, so what we have is we have the spell config and we have spell direction. First thing that I want to do is set up a cooldown timer, so you just cannot cast spells like without any cooldown. So cooldown timer, if it's not equal to 0 and cooldown timer is less than current spell cooldown, we simply return. Okay, you cannot cast a spell if it's on cooldown. Else we set the cooldown timer to 0. Okay, and how do we update that timer? Well, we simply use the process function. We say if current spell cooldown is not equal to null and cooldown timer is less than current spell cooldown timer please plus equals delta. Okay, so this is how you handle it, right? You update it until it reaches some threshold. Then we finally handle casting the spell. So spell rotation, we will equal this to get spell rotation function, where we pass spell direction and spell config initial rotation. So let's write that function, because we need to know how to rotate the starting spell. Get spell rotation has two arguments: spell direction vector 2 and initial rotation, which is of int value in degrees. And we just match spell direction. So for vector to left, we just add minus 180 and initial rotation. For vector 2, right, we do return 0 plus initial rotation. For vector to up, do return minus 90 plus initial rotation. Vector 2 down is return 90 plus initial rotation. Perfect. And you might wonder, why is that? Well, if you take a look at the spell, right, for example, for the ice and plant, I will consider the right to be like 0. So for right direction, the sprite looks good, right, for me. So then, if it looks good, I know if it looks good for the right, then for the left direction, we have to do minus 180, right? And then for down, to rotate it properly in that direction, we need to do 90. Is it 90? Where is it? Spell system. Yeah, 90. And then minus 90, right? Or minus 80 or 180, because it's the same for the up direction. That's why we need to calculate the initial direction for the spell. So we have that. And we have the spell rotation, and we can create the spell. A spell scene instantiate, that should be of type spell. Okay, we need to add it. Oh, this does not exist. Yeah, okay. Let's see, we need to add this to our game. Get 3 root add child spell. Spell direction is spell rotation. Degrees is equal to spell rotation. Then spell direction is equal to spell direction. I can call init with the configuration, so the spell config, and then spell position is equal to get parent, so our player global position. In theory, this should work. Let's try this. So I pick it up, equip it, I select the fire, and I do, oh, this is left hand. Okay, so this isn't correct. Let's see, spell direction is right. Oh, I know what it is. So in our animation, controller, we have attack direction, but instead I want to have something called attack vector, which would be calculated based on the attack direction. So I can just do var attack vector, and I could set this as a getter property, and we get this as direction to attack vector of attack direction. Okay, and then it will return me a vector for each attack direction, and I can go to my spell system and say this is attack vector. Let's try this again. pick it up, equip to left hand, press L, and here you see we're casting a default spell, which is not really good, but if I change it, well, not really what I wanted. I believe we're missing something here. Config spell name. Oh, we have some errors. Okay. There is no animation with name planned. Oh, of course. We need to do two lower. Let's try this again. Now it works. Perfect. And now we can cast different spells with different speeds, different animations. Perfect. This is almost done. There's one hard thing for us still to do. As you know, we have the cooldown for a spell, but given what we have currently on our screen, user don't know that there's a cooldown going, right? And it seems that it's not even working because I can spam this indefinitely. So we have to fix our cooldown. So go to our, let's see, spell system. Let's see what is wrong here. If cooldown timer is not equal to 0 and cooldown timer is less than current spell cooldown, return. Else cooldown timer is set to 0, and here cooldown timer less than. This looks correct to me. So let's see it. Current spell cooldown. Oh, it seems like we do not set this, right? Let's see. Current spell cooldown should be spell config cooldown. Yes, because this is a spell config which has initial cooldown. Sorry. Let's try this again. Okay, so now I cannot spam it. The one problem I can think we have here, if I select it, then initially I cannot cast it. Current spell cooldown. Oh, and in the start, the cooldown timer, we need to set it to some kind of very, very big value so that we can cast it at the start, right? So let me think. Let's do like 1000 for the cooldown timer. Let's see where this helps. Yeah, and then we have a cooldown ongoing. As you can see, I'm trying to spam the spell and the cooldown has to go through. But we do not see any information about that on our screen. So let's go to where we cast the spell. Oh, that's the line I was missing. But it's all good. So we do, when we cast the spell, so here we do on screen UI, and it's gonna be spell cooldown activated with current spell cooldown. So now going to on screen UI, we need to go to on screen UI, and we need to say spell cooldown activated, cooldown float. I'm gonna say spell slot on cooldown. Okay, so now, as you remember, the spell slot is on-screen equipment slot. So go to on-screen equipment slot, and here is one thing that we're missing currently, which is a color rect. So like in 9 patch rect, I can just add color rect. Okay, just make sure it is set to center and it has some kind of nice color. We will do like transparent pink maybe. Okay, something like that. And make sure for the, let's see, there's transformation. Let's make sure to set the size to be 0. Okay. And then what we will do is we will actually make it grow. Let's see, this is this. Okay, so we can now go to our on-screen equipment slot, and we can say on cooldown, and this is a very basic cooldown animation. We will, for the starters, hide it. We'll say, let's grab the reference to that, and we'll say color rect visible set to true, and then we twin it. So that's going to be get tree, create twin property of a color rect, twin the size, make it grow to a vector 2 of 40 and 40 with a cooldown timer, and twin, get a twin callback on twin finished. We have to reset that. So basically reset the size and hide it. Color rect size, reset it to the starting size, which is 14.0. Color rect visible false. Okay, so if we set this up correctly, now our cooldown should be visible. So I equip it, I select the fire, and I cast it, and you can see that while the cooldown is ongoing, on the left corner I cannot cast, and then I can recast the spell. So we have also our cooldown done. Good job. About the next section, I believe we have to start working on our health system. See you there. Okay, so for our weapons, spells, and health system, which is yet to be built, to make any sense, we need to create an enemy. And actually, we will create very simple enemy. This can be extended and made more complex when it comes to AI by using stuff like let me show you real quick. AI state machine for Godot. So you will find main tutorials about this. I also can recommend Godot behave, which is like a set of nodes for more complex AI behaviors, for like behavior trees. So these are two good approaches when it comes to creating AI. I will try to keep it simple to actually be able to, well, finish recording all of the stuff that I have prepared. Okay, so let's do a new scene. It's gonna be character body 2D. Let's call this enemy. And let's save this in our scenes. And we'll of course create a script for that. Okay, we get rid of everything, and let's start by setting up our node. So what we'll need is animated sprite 2D, and we'll need a collision shape. Okay, and we'll also need to detect the collision with a player. We'll need area 2D and collision shape. For that, let's first handle our animation. So let's create new sprite frames, and we will actually use the beast here, that sprite sheet, but there are other options for creating enemies. As I said, this sprite pack is really cool. So we need to define some animations here. Back idle, back walk, died, front idle, front walk, left idle, left walk, right idle, and right walk. Let's go through those from start to end. So we'll go to sprites, actor, monsters, beast 2. Now let's see, this is 4x4, which is correct, and we're working with back idle. So this is back idle, then back walk. I believe that's the one. Go to 2D, and let's play this. Well, yeah, that's it. For died, this is quite different. I would like to search for, I believe that should be in FX. Smoke. Let's see. Yeah, that's the one. So let's grab this. FX, smoke, sprite sheet. And this is 1, 2, 3, 4, 6 horizontal. No, this is 1 horizontal, 6 vertical. No, this is the other way, 6 and 1. Perfect. Let's go from start to finish, and this is our died animation. It has to be a little bit quicker, so let's make this 15. That's good. Also for the back walk, I think that doing like 10 FPS might be better. Well, no, this is too fast. This just looks strange. Let's keep that 5. Okay. Then we do front idle. Front walk. Left idle. So this is left idle. Left walk. Right idle. And right walk. Perfect. And we have everything prepared when it comes to our animation. Let's see the collision shape, since we only have one type of enemies, and you know, we could like do more, but then this course would be even longer. But I hope with that you will be able to at least start with your own enemy type. So going here, going to do, what kind of shape are we doing here? Just rectangular. Okay, makes sense. Let's do something like this. And actually we'll reuse it, so let's save this. Save as, go to resources. Let's see, this is going to be like enemies, and I will do, what can I do? I will call this beast collision shape. And then I can reuse it here. As beast collision shape. Perfect. We have that set up. And we will need a health system. And this is going to be a very simple reusable node. So let's grab this, let's call this. And we will be able to attach it pretty much to anything. Health system, let's save it. Do scenes. Nothing there, just a simple script, but making this a separate scene will allow us to compose it into all other scenes that need health. It's gonna be stupid simple. Class name is of course health system. It emits 2 signals. We give it a max health. We store the current health. We give it an init. We initialize it with a health and set the current and max health to health, and we do function apply damage. Current health. Let's current health minus damage. We do damage taken, emit, damage, and if current health is lower or equal 0, we just emit died. And that's it. That's enough to handle our health. So going to our enemy, I can just instantiate this. Let's see what value can we give to a health. Let's say 100. Okay. And then we can start coding. So class name, enemy, will export speed. We'll export the patrol path for him so that he can walk along a path. And we can do it two ways. We could do array of vector 2 or array of markers. We'll do array of marker 2D just for fun. Then we do patrol wait time. We will do damage to player. We will do health. We will do item to drop. And we get the reference to stuff that we need. So this is animated sprite to the health system. Oops. Health system. And we'll also add a progress bar indicating the current health. So let's just add a progress bar. Show percentage do not. Let's see, max value step is going to be 1. Let's see, in the layout, we need to set some stuff here. So the size will do 20 by 4. Anchor preset. Top left is good. The position we can do -10, -14, so that it can be above. Then what else? Rounded. Didn't want it to be rounded. And then basically the one thing that is left for us is to create the styles. So that's going to be theme override, styles. We have background and fill. And since we will be reusing that, I'm thinking maybe we can save it to be reusable for our player. Let's figure out this first. So we need new Starbucks flat. It's gonna be just all black. And then we will do the fill. New Starbucks flat, which is going to be all red. Well, this is like orangey red, but this is fine. Then if we increase the value, come on, if we set the value to, I don't know, 50, yeah, this is correct. This is perfect. And we need to go from end to begin. Yeah, and actually we can save branch as a scene and go to scenes, and we call this health bar. Yeah, I believe that's almost everything. Oh, we will also need a script for animated sprite 2D. So I'm thinking, let's handle this first. Let's go to scripts and do enemy animated sprite 2D. And let's get coding. Class name is enemy animated sprite 2D. We do movement to idle dictionary. Backwalk translates to back idle. Front walk translates to front idle. Right walk translates to right idle. And the left walk translates to left idle. We start the last direction, which is going to be 0. And then we just write two simple functions. Play movement animation based on the direction. And we need to prevent like him just staying in place. So if direction, because we will be moving across a path, and we need to compare the changes in the state between idle and the movement. So if this is less than 0.1, just return, do not do anything. And then last direction is equal to direction. And now we can play the animations. So if direction x is greater than 0 and absolute value of direction of x is greater than absolute value of direction of y, play right walk and return. Else if direction of x and it is less than direction x absolute float value of direction of y, then play left walk and return. If direction y is greater than 0 and absolute float value direction y is greater than direction x, play front walk and return. and else if direction Y, also comparing the very same values. Direction X, play backward, and return. Even though we don't need to return here, it's the end of the function. And then play idle animation is going to take a look at movement to idle keys as animation, just play movement to idle animation. Again, this all could be handled by animation tree, right? But it's so simple that we can do it by hand. Okay. So this is play idle animation. This is the animation controller for our enemy. And then we can go back to just enemy script. And let's see, we need our reference to the progress bar. So let's grab that. And we need current patrol target. It's going to be 0. Wait timer, which is going to be 0. And then I want my enemy to drop something when he gets killed. So I will search here for the pickup item scene to be able to do that. So in short, this is going to be stupid simple when it comes to how an enemy would behave. He will just go from point A to point B to point C. Right? When player touches him, he does damage to the player. DMG. When player hits him with spell or weapon, he takes DMG. When his health goes to 0, we just play that died animation. And we drop the loot, right? So we instantiate some kind of inventory item, be it gold or anything else. Cool. So let's start. On ready, we need health system to be initiated with his health. We need progress bar max value to be set to health and we need, let's see, progress bar value to be set to health. And then if patrol path size is greater than 0, we set his position to be patrol path 0. Position because this is the marker to D. And health system died connected to on died. Let's create on died. We do set physics process false, and animated sprite to D we do play died. And then we also need to disable the collisions. So I'll grab both collision shapes. Yeah, and they're named the same, right? So I'll call this area collision shape, and we disable both. Okay. And then let's see. We will do apply damage. We'll pass this to health system. And let's see, we need to connect to animation finish here. Let's see. On animation finished, perfect. We need to check whether the current animation is died. So did we finish playing that smoke animation? We'll create a loot drop. We will do drop loot drop inventory item equal to item to drop, and we'll do drop loot drop stacks is equal to item to drop stacks. Get 3 root add child drop loot drop drop global position sorry, it's loot drop global position is equal to his position, and we call Q3. So this is how you can drop some loot from the enemy. Let me think. Okay, then there's just a matter of implementing physics process, and if patrol path size is greater than 1, move we will do move along path with a delta. So this is the function that is actually going to move our enemy through those points. Okay, so move along path with delta mean float. Let's see. Target position is patrol path current, how do we call this? Current patrol target. Okay. And the direction in which we are moving is target position minus current position normalized. Then distance to target is position distance to target position. And then we just do if distance to target is greater than speed times delta, we just do animate sprite 2D, play movement, play, what do we call this? It's actually enemy animate sprite 2D. Play movement animation, direction, velocity is set to direction, come on, velocity is set to direction times speed times delta, and we call move and slide. Else, if we're close enough to the point, we will do a little bit of waiting, because I want him to move and then wait, move and then wait, so he just goes and stops. So if he's close enough to a target, he will wait. So animation sprite 2D, play idle animation. Position is set to target position. Wait timer plus equals delta. And if wait timer is greater than or equal patrol wait time, do wait timer, we reset it, and we update current patrol target, and we do current patrol target plus 1 modulo patrol path size, right? And this simple operation, if you don't know, will allow you to go through array indefinitely, because let me explain this to you. Let's say that we have 4 entries in our patrol path array, right? And what we do here is current patrol plus 1, so we increment this, and we do modulo, which is like a leftover from division, from patrol path size. So the size is 4, so we do 0 plus 1 modulo 4 is 1, right? So we never go outside of the array. For example, if we have 3 here, we do 3 plus 1, which is 4 modulo 4 is equal to 0, then 4 plus 1 modulo 4 is going back to 1. So we can just, so he goes in a loop through those points. Okay, let's actually try and set this up and see whether this works. So I will do Ctrl-Shift-A, grab an enemy. I will put him here, and we need 2 things here, patrol path and item to drop. So when it comes to item to drop, I can just do, I believe, gold coin, right? And I could also do stacks here. Let's see. Let's see, how did I define this? This is inventory item. So this value goes from item to drop stacks, which does not exist. So maybe it's better to just define it here. Let's say loot stacks. Let's do 10 by default. because different monsters should drop different amount of, I know, gold or items. And let's default this actually to 1. It's smarter to do it this way. Okay, going back here and here. Let's see. Loot sacks, I will do like drop 15 gold. And then to make him move, I will create 1, 2, 3, 4 elements. And I will do not empty node, but node to D to group the enemy patrol path. And let's add a marker to D here. Okay, he has to start here, then go here, then go here, then go here, and I will click on him and say this is first marker, second marker, third marker, fourth marker. Okay, let's see whether this works. Okay, object and vector in operator. So target position, what is that? Let's see, target position. Oh, we need to grab I know, global position from that because it's a marker. Okay, he goes really slowly. We need to increase his speed. Let's do it like 10 times bigger. Now he goes. Oh, he kind of snaps to position too fast. This is because of the speed. If I were to remove the delta here. Let's see how that works. Almost good, just a little bit too fast. So what we can do is first check the animation because I think there's something wrong there. Let's see, idle walk, right walk. Okay. Let me check this again. Goes left, he stops, he goes down, and he continues walking. But here he walks for some reason. Let's check our script for animation. Let's see. Back idle, front. Yeah, there's a typo here. That's why. Okay, and maybe going back here. The speed, let's decrease it. Okay, so we have our enemy. Nice. We have that set up. So in the next section, we need to handle actually fighting our enemy. Okay, so we have few things to handle in this section. One is that I cannot actually interact with the enemy. Like I can just bam a little bit, but nothing happens to my player because we have no health system. That's one thing. And the other thing is that we have no means of damaging him. So let's start by working on damage on our player. So going to our player, what we have to add first is some kind of health system, and actually we have a node for that, I believe, so we can just plug and play it. Then of course what we need to do is in our on-screen UI work with our progress bar, which currently, as you can see here, does nothing. So we need to actually make it work. Let's see. Let's set the custom minimum size to be. Oh, let me give you mouse highlight. So it's going to be 200 by 16. And then we're going to go begin to end. This is fine. And then we have to set the styling. So styles. Let me check. Do we have styles for that? Not really. Maybe we can reuse the ones from the enemy. Let's see. Theme override styles. Yeah. Basically, what we can do is turn those into resources. So let's save as, and this is background. It does not belong to the scene. Let's make unique. Let's do save as, resources, UI, and this is going to be health bar background. And this is going to be make unique, save as, health bar heal. With those resources saved, I can go to a player, go to on-screen UI, sorry, and here I can just quick load, and this is background, and then this one is field, and let's see if we set the value to 100, it is being filled. Perfect. So what we need to do now is write a simple function to initiate the health bar and apply damage to health bar. So we need a reference to that. And then I can just write 8 health bar max health progress bar max value is equal to max health, and I can say apply damage to health bar is equal to damage int, and I can just say progress bar value minus equals damage. Okay, and this of course should be used and connected with our player, right? So let's go to our player. It's just, yes, this player script, and we can use the ready function for that. And I can say, let's see, we need a health system, and we need to reference to on-screen UI. And I can actually export a variable here, export var health 100. Then in ready I can say health system init health health system dot connect. We'll write on player dev function. We'll also handle taking damage here. Health system damage taken connect on damage taken, and on screen UI init health bar with the health. With all of that arranged, we will start writing our functions. So we need on player dead and on damage taken. Let's start with on damage taken. we'll use on-screen UI to inform that we need to apply some damage to the health bar. Okay, and then on died, right? On player dead. What we need to do? Well, we need to set the physics process to false. It's one thing. Cannot find properly connect. Yeah, a typo. Okay. In the identifier damage not declare another typo. Let's handle that. Okay, so we disabled the physics process so that we cannot move anymore. We need to disable the also a possibility to attack, so we need reference to combat system. And then let's say combat system set process input false. And then for animated sprite 2D, we need to play dead. And just to make sure that we have that defined, no, we don't. So let's actually add from frames, and this is going to be white fighter. And let's see, I believe this one looks dead enough. So this is 4 and 7. And we need to create new animation. Where did I add this? Oh, here. Okay. Oops. Not what I wanted. Let's remove it from here. And then find that and apply that frame. Perfect. So we have all of that basically. What else do we need? Because right now if we play it, we should see the health bar, but still when I actually walk past my enemy, nothing happens. So we need to find a way to apply the damage, and this is going to be on area to enter. So for now we're checking only for the pickup, right? So let's see, if area get parent is enemy, I can say damage to player is equal to area get, let's do get parent. We can cast this to enemy. Damage to player, and then I can call health system, apply damage to player. So that should be the possibility for us to actually get damaged by our wonderful enemy. The problem now is that I can like push him around. So let's see, here in my player I can interact with decoration and ground, and when it comes to enemy and the collision, yeah, he shouldn't be on that layer. He should be on layer, let's see, enemy, and he should collide with ground and decoration if needed. And here in area 2D, Let's see. We should also place it in enemy. Oh, sorry, we should place him in enemy and allow him to interact with the player. So if we set up properly, collision, no more pushing around of our enemies, which is great. And then there's just a question of why the health system isn't triggering correctly. And if we go to the player area 2D, this is of course because we do not allow the area 2D to collide with the enemy. So let's check that mask and let's try this again. And now as I'm going through the enemy, I am losing health and I should even be able to drop dead, which is perfect. So the next step is to actually be able to damage our enemy either via weapon or either via spell. So maybe let's start with a spell. It has a collision shape. Let's see. This should be treated as a weapon and it should collide with enemy if I'm correct about this. So let's see. What we can do is we can just hook up to on area entered, connected. Okay, and I can say if area get parent is enemy, I can say area get parent as enemy, and it should have apply damage, and we will just apply damage of that spell, and then we of course QE free. And let's test that by picking up the spellbook, equipping it, and selecting fire. And this was okay. This is here. Let's try hitting our enemy, and it seems like nothing happened. So let's check that. Okay. Let's step down. Area is apparent. Damage is 25. Apply damage. So the damage should be applied. Maybe we just don't see this. Let's see. Apply damage. Yes, we don't update when we apply damage to an enemy. We don't update the progress bar. So definitely something we should do. Let's see, this is calling health system apply damage. And then let's see our progress bar, which can just add a script here to solve that issue. So let's call this, I don't know, health bar. Might work. Okay, create. Let's call this enemy health bar. Let's get the reference to health system. And I can just say visible, we'll hide it at the start. Max value is equal to health system max health. Value is also equal to max value, and we'll connect the signal damage taken. If it's not visible, We will turn it visible. And we'll remove the damage. I mean, decrease the value. Let's try this again. Okay. Okay, there are two problems here. As you can see, one thing is that so when we kill an enemy, we get into a loop. So first thing, let's check the diet. It should not loop. That's one thing. So let's disable that. Other thing is when we get information about the diet animation being finished, we should just remove that node. So let's actually hook into animation finished. Oh, we have that. So maybe it was just the looping case. Let's see. Let's choose a spell. And this is, left hand. Okay, and we have a loot drop. Perfect, there's error though. Let's see. Can change the state while flashing curries. Okay. So maybe let's change the order first and let's see. Equip it. Grab it, and I did not hit it. Long cooldown there. Again. Okay, still an error. Let's see. Can change the state while flashing curries. Okay, let's try using set deferred. Disable true. And we'll do the same above. Okay, no errors. Perfect. And we have our loot drop. So we have that handled. The other thing that I would like to handle is, of course, using the weapon on my enemy. So going here, let's change that from shield to actually being a sword. Okay, and if I equip it and try to attack my enemy, see that it is taking no damage because we have no collision for that. And this is an easy fix. We will just go to our combat system. Okay, and we need to connect to our player. We have combat system and we have area 2D. So let's just write the connections into combat system, go into node, area entered, connect. We want to connect to a combat system on area 2D, area entered, connect it here, and connect to the same signal from here. So again, clicking on combat system. And now these two signals should be connected to that one function. And this is actually, we could actually do on body entered. So let's disconnect. Let's get rid of that. And I will connect with body entered. Again, pointing to combat system node. And from here, again, body entered, combat system node on area to the body entered. Okay, so what I can do is I can just check if body has node health system, right? Because all of our enemies will. And then I can say, I need to know which weapon is active, right? So I have right weapon and left weapon. But let's just make it work for right weapon because that's where our sword and our axe can be. So if hand type, so actually we can write it in one line. Hand type is equal to right. I can say body find child health system. And I can cast it to health system. And I can say apply damage. And that's going to be right weapon damage. Let's actually extend it a little bit. Hand type is not defined. Oh, right, because we connected to both of these nodes, and I don't know which weapon is active, but I really don't need to, because I can say that this is additional argument that I'm going to pass through a signal. So I can go here and edit that signal and say advanced, and I can give it extra string argument, right? And I can say the value of it is right, and connect. And then here I can do the same, go to edit, add string extra argument, and say that this is left. Okay, and now let's see whether that works. So I'm picking up a sword, I'm equipping it, I can attack with it, and then nothing happens. Okay, this is probably due to the fact that we need to set up the collision. So weapon connects to enemy, and here we have the same. And the issue will be with our enemy collision setup because it exists on layer enemy, and it should also listen on a mass collision because we are actually setting up our signal to listen for body collision. So let's try this again. Oh, and here we have what we need. So as you can see, the additional argument can be passed to a signal, which is really cool. So this should work. Invite access. Let's see, there's an error. Invite. Let me try and run it again. Okay, so it looks like right weapon doesn't have damage. So let's check our weapon item. And let's see. Yes, it does not have damage. That is not a problem. Let's export the default damage. Let's say 15. That will make... Let's go to our resources, our weapon, our sword item, right hand weapon item. As you can see, it has a damage. So that was the property that was missing. And with that, but yeah, there's gonna be one problem, you see? If I equip it, and even though I'm not attacking, I can do damage, right? This is because we have it on us and the collision is enabled from the start, so we need to disable it. So going to player, combat system, and let's see. We need to correctly enable and disable collision shapes on our weapons. Let's see, on attack animation finished, what we need to do is get left hand collision shape and set disabled to true. And also when we set active weapon, I believe we need to, or by default we can have those collision shapes disabled. So let's disable those. Okay, and then only when we attack we need to actually enable the collision shapes. So let's see, perform action, weapon in hand, we have weapon item, we have sprite, perform action. What we don't have is the collision shape. So I can add argument here. This is right hand collision shape and this is left hand collision shape. Collision shape 2D. And then I can say collision shape disabled is equal to false. And that should prevent the issue with me applying damage. Yeah, as you can see, now we're not applying damage when we don't attack. And then attacking, we can kill the monster and we pick up the gold. So yeah, this is like the very basic combat system with a basic enemy. The enemy types could be extended to shooting enemies, magical enemies, bosses, of course. But again, this would extend the length of the tutorial. So I believe that the next step for us is taking a look at how we can set up a simple merchant system. And we'll start that by creating a shop in which player can enter and then doing the scene transition. So I see you in the next section. Okay, so let's start with a basic setup for our wonderful merchant, and let me just show you how it's going to work. So what we will have on our grid is going to be a building that will represent a shop. have an entrance, which will be area 2D. And if player enters this area, we'll perform a scene change into like the inside of a shop, and we'll have a merchant there. And you could go to him and open the merchant UI, which will represent like your inventory, merchant inventory, and your inventory, and you can basically trade the items back and forth. So that's the plan. To start with it, we need to find a proper asset representing the shop, and we can create another time up layer. I will call this shop layer. We could do with a PNG, but the problem is that I believe everything here is represented in our grid, so we are searching for tile sets, and we have the floor. We could go with Tileset house, right? So let's go here. Probably we can reuse the same tile set. So any of this building could be a shop. I believe this one, for example, looks nice enough, so I can just drag and select. Oops, that's a little bit too much. And I can just place it anywhere. This is fine. And if we play it, naturally, we are able to work around it, which I don't want. So we need to add some additional collisions here. So going to tileset, tileset house, sorry. Let's see. No tile selected. Why isn't it showing? Okay, I just move off to match. So we have that building going to a tile set. We need to specify the physics layer. So I can just say, don't want you going around anywhere here. Here we'll set up a separate area 2D. This could probably be achieved with a tile layer, but again, we can just add another node. Okay, so now I am able to just walk through here, which is fine because I can say, I can create new node, which is going to be area 2D. Let's grab it, put it here, give it collision shape, rectangular collision shape, something like this should work. And let's see, for collision, it should collide with the player, and I can tell that this is, I can create new layer into the physics. I'm gonna just call this entrance. Okay, perfect. So let's call this is entrance, and we can work with that. Wonderful. And I will create a very simple script here. Let's see, let's call this shop entrance in scripts, shop entrance. Okay, get rid of all of that. So what we need to do is actually perform a scene transition here. And to do that, I will create like global script. Let's go to project settings. Let's go to auto load, and I will call this transition change manager. Let's add this, put it into our scripts, create. This should be a global variable. Perfect. And let's see where we can open it. Transition change manager. Perfect. Okay. I believe we should also make a scene for that and make it extend canvas layer. So let's see. Yes, let's create that. So name, path, global variable, this is all fine. I can just create scene, new scene, other node, canvas layer. I will call this transition manager, because what we would like to get is this nice fade in, fade out effect. And to get that, I'll just add a correct and simply make it span across. Okay, changing the color to fully black. And then we can add the script. So where do we have it? Scripts, transition change manager. I can just drag and drop it and start coding. This extends the canvas layer. Let's give it a class name. And we will output one signal called transition done. We'll export two variables. One variable, transition time, which is going to be 1 second, and we'll get the reference correct. Let's see, we need next scene path, which is a string, information about where it is transitioning, and player spawn position into new scene. Okay. And then we need information about the ready. Let's start with ready first, of course. We will disable it by default. So we'll set the alpha to 0. And set the correct to be visible. Or we don't need that actually. Then we need a fade out function. Let's reset the alpha to 0. Let's make sure that the color rect visible is set to true. Then we need to create a twin to modulate our alpha. So I can just say, maybe let's bring that down. Let's twin property. This is color rect modulate alpha. And as you can see here, we can go and access particular keys of given property by using colon. And twin finished connect to on fade out completed. Let's write that function. On fade out completed, we'll do get tree, change scene to file, next scene path, fade in, and we'll call the fade in function. So at the start, we make sure that the color rect modulate alpha is set to 1, and we create the twin to bring it back to 0. Twin property is the same. So modulate alpha, 0 is the final value, and then transition time is the same. And then we do twin finished connect on fade in finished. On fade in finished, we set is transitioning to false, and transition done emit. And with that, we can do change scene function, where we pass next scene path. If we are transitioning, then we return, and next, let's say self next in path is equal to next in path, and fade out. Oops, fade out. So now we have ability to actually, sorry, I missed the con there, to perform the scene change, which is great because going to our main, we have that area which we recognize as an area to actually be a scene change entry point, and we can just say on body entered transition manager. Let's see. We should be able to set the player spawn position to vector2 0 0, and then we need a new scene to change to. Cannot find member player spawn position in base transition manager. Let's see, it should be there. Is it because it is okay? Oops. It is transition change manager. Okay, because that's how we called the global variable, right? Even though This is the class name, transition manager. The global variable name is transition change manager. And then I can create like an empty scene. Let's see. That could be just an empty node. I will call this shop scene. Let's save it. And then going back to our main area, I can say transition manager, change scene, and we need the shop scene. So this is, let's get a reference to that, shop scene. Okay, and let's see. Invite access to property or key modulate on a base of null. See, transition manager. Okay, so the problem with this error is that we are for now actually autoloading a script instead of autoloading a scene. So let's get rid of this, and what we can actually do is click here and choose the scenes and find transition manager. And we can, okay, so change it to transition change manager, so to avoid the namespace collision. And then it will autoload the scene instead of autoloading a script. And now it works, and I can go here, and again nothing happens. So let's see, this is probably because our player is not set to collide with that. So let's see, this is entrance. Okay, so going to our player, to our area 2D, we need to allow to collide with entrance. Let's see, still nothing. Let's see if that triggers. It does not, so going back to main. Let's see, this is 7 colliding with 1, and we're listening for body entered. Okay, so if we're listening for body entered, then we need to check that mask on our body instead of area. So I can uncheck this. And still nothing. Entrance. Collision layer is 7. And player 1. One and 7. 7, 1. Okay, so the problem is when we cannot enter this area, this is because I did not actually connect to a proper signal. So I am going to cut this, remove this, and for our area, which is entrance, I will go to a node and connect with body entered. Select the proper node, which is the area 2D, press connect, We just pass this, and then when our player goes into a shop, we transition the scene. So in the next episode, we'll actually start working on our shop scene. See you there. Okay, so in this section, we'll actually set up the shop scene as well as handle transitioning between in and out of the shop scene. The shop scene is actually empty right now, but we need to set up some things. So let's start with the timer player, and let's probably load the very same tile set. Let's search for entrance. I mean the inside of the shop, and I don't think we have this one loaded, so let's see. Floor, load house UI, there's a lot, as you can tell. There are some walls, water, abandoned village. We're searching more of a house. Let's try Tileset element. For some reason I cannot add this here. Let's add Atlas, asset, sprites, background tile sets. Interior sounds like a good plan. Tileset interior floor. Let's see. Okay, yes, so we have something here. Probably we also need the walls. So let's see. Let's try element. Oh, there's interior. Okay. So yeah, we can work with that, right? Let's create some space here. So let's just grab this and start painting. This is going to be rather simple. We'll just create some simple space and add some walls around it. Oh, that does not look correct. Let's try this one. Okay. Then this one, I will just make it barely functional. And then an entrance here. Let's see how we can get those connected. Okay. Let's try adding elements to the tile set. Maybe there's some kind of door there. Does it look like a door? Maybe. Okay, let's go to a tile map. Well, it does not look too good. Let's see. Tileset floor element. And not a door inside. Okay. We can work with that. So this is our wonderful shop. And we will actually need to move some stuff around, but let's start by adding a merchant. So let's see, we need a character, actor, character, master, looks nice. Maybe old man, that looks good too. So let's actually add a sprite. Let's drop the old man here. So texture, sprite sheet, and we of course don't want all of that, so we need to set the region for that. Edit region, snap, let's do a grid snap. Okay, close, and now we have our wonderful merchant. Let's see. I will give him a collision shape, rather collision area. So let's add area to D. Let's do circle. And let's extend the radius. So anywhere within that radius you are, let's set it to 50, you can interact with the merchant, which is really cool. I will add a new layer, call it merchant. And in collision, set this to merchant and to interact with a player. Okay, we need of course the other area to D to work as an exit. So to that, call this exit area. Give it collision shape to D. Let's do a rectangle. Let's move it right about here. Okay, so we have that set up, and let's do some coding when it comes to our shop scene. So what we need to do is spawn our player when the transition is done, and also place the player in the correct space. So I'm gonna add by finding marker to D. I'm gonna call this player spawn place, and let's move it around here. And then what we need is a reference to a player scene, because we need to spawn our player. So call this player scene. We will need the reference to the marker. Or better yet, yeah, we can do the marker. So player spawn place marker. This is good. And we can start coding. So we have access to global transition change manager, and we can listen on transition done and connect on transition done. And in on transition done, we will just allow player to be controlled. So we will find the player node and set physics process to true. Then we will say that we need a player, which is a player scene instantiate. We'll add the player to a scene. We'll say, let's see, if transition change manager player spawn position is not equal to null, we'll say that player position is equal to transition change manager player spawn position. Actually, do we need this? Not really. We can just say player position is equal to player spawn position marker position. Right. And that should be, in theory, that should be enough. So let's see, we're going here. And we are here now. Okay. Now we need to be able to transition back when going through here, right? So we have that exit area, and I can connect to the main node. So body entered. So what we do here is we say transition manager, transition change manager, let me think. We need to change the scene, so transition change manager, change scene, and let's get reference to main scene. And then in the main scene, we need to set up our player. Let's see. So we need to add the main script. And here we need to say we need to grab the reference to a player and set his starting point. So again, we will use marker 2D. Player spawn point. And where is it? Here, I can move it here. Grab the reference, and on ready I can say player position is equal to player spawn point position. Okay, so I am able to go here and go here and go back. The one problem is, I can go too fast into, let me show you. What can happen is I'm in the shop and I have this area and the transition did not finish yet, but I'm already going back to transition to a main scene. So basically we need to disable the possibility of movement until the transition is done. So go to shop scene. And let's see. We need to say at the very start, the player set physics process is set to false, and player, set input, set process input is set to false. And only when the transition is done do we say player set physics process true and player set process input true. Okay, so I'm going here. I can move already. Right, but I can, yeah. Let's see. Set process input false. Okay, so somehow I can move before. Let's try this. Oh, now I have, yeah, now it works. Now I have to wait for the transition to be done. So I cannot move, and only then I can move again. Perfect. The same could be done in our main scene. So we have that, and then we just say player set process input false, player set physics process false, and then we do transition manager, transition change manager, transition done, connect on transition done. And we just re-enable those. And it's going to be problematic at the start because we are starting in our transition change manager. So what we can do is just say if transition change manager transition is transitioning, then we will do it. Okay, this works. We're going here. Cannot move. We're going back here. Cannot move, and I can move back. Perfect. So that's how we can transition between the shop scene and the main scene. The next section we'll start working on the merchant UI. See you there. Okay, so what's left for us to do is to actually get our merchant system working. And to ease the pain of setting everything up, I'm gonna actually start by writing a simple function in our player. So to test the merchant system, I will create a function called setup test inventory. And what I will do is I will get the sort inventory item, and I will get the gold item. And let's add those to inventory. So it's just a matter of going inventory, add item, sort inventory item 1, and inventory, add item gold. Inventory item can add like, I don't know, 100. And then when we go to our shop scene, we can just call player setup inventory item. And if you run this scene, let's set up this item. Test inventory, sorry. Right, and now, okay, and also when running this scene, I cannot move, but I can see that in my inventory, I have my sword and my gold. To fix the problem with no movement, we can just do if transition change another is transitioning, then block the movement. Okay. And now rank the shop scene. I can move and I have my things. Now, with that, I know that this is the merchant. Right, and I will actually turn him into a separate scene. So let's do save branch as a scene, go to scenes, merchant, and save. This is now perfectly working merchant, but as a separate scene. So going to shop scene, I will add the new script to our merchant. So let's do that. This is going to be just a merchant script that will allow us to trigger different things. So let's do scripts and merchant and create. Okay. So what we'll do with our merchant is we'll add two things to him. What is going to be a label? Let's position it above him. Oops. And we'll say press M to shop. Okay, above that guy, let's make sure that we have the proper font. Set this to center. Okay. Yeah, and we should attach the script. Load it and start working. So we'll need a few things here. One thing is actually the action to trigger the merchant. So this is gonna be, let's call this merchant. And that's gonna be M button. And then I can say that this class name is merchant. And it actually has items to buy, which is an array of inventory items. And then in our shop scene, I can say that it has a size of 1, and for example, he sells a let's find it, shield inventory item. Of course, you can pass here as many items as needed. And what we need actually here is the reference to label. And we will also need a separate scene here that we will call, let's move it out. We'll hide it and we'll call this shopping UI. And let's also make it a separate scene because it's gonna be a little bit complicated. Okay, but already I can get a reference to it. And then we need information whether we can trigger the shopping UI. And trigger merchant UI, and let's set it to false at first. Okay, and then we'll go here and add a script. This is going to be shopping UI script. Just to have everything prepared. And we'll export two things here. But let's start with a class name. We have items to buy and items to sell. Okay. Going back to our merchant. At the start, we'll call ready. Of course, and we'll set that shopping UI items. Let's cast this to shopping UI. Items to buy are equal to items to buy. And we also need to set up buying grid. So let's create that function. And for now, let's allow it to pass. Okay. We need the information about somebody just going in and going out. So let's connect to body entered. And let's also connect to, oops, remove this. Let's connect to body exited. On body entered, we'll do can trigger merchant UI, we'll set it to true, and we'll set the label to being visible. Also true. Then on body exited, we'll do can trigger merchant UI, we'll set to false. So set the label visible to false. And if the shopping UI is visible, we'll set it to invisible. Okay, let's run this and see how it works. Invalid assignment. Items to buy. That's a typo. Okay. Oh, we ran the merchant, not the shopping scene. Let's try this again. Okay, and now you can see that when I'm in the vicinity of the merchant, I can trigger that label. Of course, we need to handle on a proper need to listen on a proper input to make it work. So let's do input. If input is action just pressed merchant, we need to do a few things here. So if we need to check where we can trigger the UI, then we do shopping UI visible equal to true. And then we need to get the reference to our player. And there are many ways to do it, but what we'll do actually is go into our player scene, node, groups, and we will add this to a group. So add a group, call this player group. And yeah, just like that, he's in a player group. So then in Fury, I could go to a merchant. And I should be able to say player is equal to get free, get first node in a group, player as player. And let's see what we find there. Spoiler alert, should be the player. Oh, not that scene. Actually, what I can do is find the shop scene, and for now I can say that this is main scene. Okay, so I'm pressing M, and the player is an object, and it is a player. Perfect. So we can globally access player in a scene via group. And then I can say shopping UI items to sell is equal to player find child inventory as inventory items, and I can say shopping UI setup selling grid, which we need to create. And we'll pass for now. And then I can say if input is action just pressed, and this is UI believe cancel, which defaults to escape, and shopping UI visible shopping UI visible is equal to false. Okay. Yeah, for now it will actually give us nothing because the shopping UI items to sell is not available. Let's see. Items to okay. Try this again. Okay, nothing happens, but if I go to remote, shop scene, merchant, now you can see that the shopping UI is visible because of that icon. Whereas for a merchant, it starts hidden. So we actually trigger it correctly. And in the next section, we will actually build it and make it work. So I'll see you there. See you in the next section. Okay, let's try finish this last piece of functionality in our game. So building our shopping UI, let's start by building the nodes first. So I will add a margin container, and in theme overrides constants, let's do 16. Then let's add a color rect. Let's do with a little bit of alpha so we know what is behind. Maybe like a nice bluish color, something like that. And then we need HBox container to split it into, and of course let's make it visible, and let's make it span across the whole screen. Okay, then we have HBox container, alignment, set it to center, and also make it span across. Then we'll have two columns, so add VBox container and another VBox container. Let's go with custom minimum size here of 500, and here also 500. Okay. This is going to, the first one is the merchant column, and the second one is the player column, and we can even throw a V box. No, this is a V separator, just for a good measure. Let's see how we can style it. It's gonna be all black. So theme overrides, style separator, new style box flat. Let's go with all black. Separation is set to 1. Okay. In a merchant column, let's add a label at the top. Call this merchant. Center, load our theme with our font. Maybe let's make it slightly bigger. So I don't know, like 20, or I don't know, 24. And change the color to black, because why not? I will copy it and paste it into, oops, I will copy this and paste it here and change it to player. We will add a grid, so this is going to be grid container with 4 columns, and call this, let's call this buying grid container. Do the same here, call this selling grid container, and below we'll add the button, and that's gonna be like buy button, and we can also load our theme. Yes, and then here I'll just say sell also load our font. Okay, this is looking good. So now if we go to our merchant and press M, we see this UI. Maybe we need even less alpha here. I mean more. So let's do like 240. Okay, I believe this looks, well, acceptable. Then it's time to actually do the coding. So let's start with setting the buying grid. So let me see. We will also treat those functions as functions that reset the grid. So for child in, oh, we need references to our wonderful stuff. So let's access as unique name, and let's access the second grid as unique name. And let's get references to that. Buying grid and selling grid. And also this is going to be the buy button, and this is going to be sell button. And we need references to those. So you can also make unique names. Buy button, sell button, oops. And we'll need to track selected sell item indexes, which is an array of int. I'd like to know which items are selected to be sold and which items are selected to be bought. Item indexes. And then we go with setting up the buying grid. So for child in buying grid container, get children, will clear the grid at the start, and then we'll set up everything that we need. So for I in items to buy size, let's see, we miss colon and we miss it here. We'll create new buying slot, and we need the reference to inventory slot because we can reuse it. So maybe here, inventory slot scene. And I can say inventory slot scene instantiate as inventory slot, and I can say buying slot is single button press type. We add the child, and we say buying slot, add item, items to buy at I, and we don't need double parentheses here. Buying slot, we don't have, what we need is show price tag function there. So let's go to inventory slot. Let's open inventory slot scene, and we have price label, and I can just say we have a reference to it. Yes, we do. Show price tag price label text is equal to pass it to a string plus gold, and price label show. And now I should be able to call that function. Perfect. So we have that be available, and that should be of item to buy at I, price times items to buy at I stacks, because that's the price for the whole slot. And then buying slot clicked, connect to on buy slot clicked, and we bind the I, and I can write that function. So let's do this. What should happen when we click on the slot? Well, we should add it to the possible to the items that we would like to buy, right? So on buy slot clicked idx int, and we check first if selected by item indexes. So did we selected it already? Else. Okay. So if we did, we can do buying grid container get tiled idx toggle button selected variation to add the border, just like we do with the spells. And we can say selected by item indexes erase idx else. So if we are actually selecting, not deselecting, buying grid container get tiled idx toggle button selected variation through selected by item indexes append idx, and then we check where we enable or disable the buy button. Disabled, selected by item indexes size equals 0, and that means that we should start with our, let's go to shopping UI scene. We should start our buy button disabled, and the same goes for the sell button. So let's go to, where is it? Disabled. Okay. So let's try and run it. And there's some kind of problem. This is no longer canvas. Oh, of course, this is not JavaScript. Okay, so I press M, and hey, we have our wonderful merchant shield presented here, right? The problem is it doesn't seem to work as good as I wanted. So I click it and nothing happens. Buying slot clicked, on buy slot clicked. So this should work. So the problem is that currently we cannot select this or any other button for that matter. And I think what the problem is that in our shop scene, we are the merchant UI is being overshadowed by the on-screen UI. So what we can do is compare the layers here. So the on-screen, let's go to a layer, and the on-screen UI layer is set to 1, and then our shopping UI is also set to 1. So if we just bump it to 2, so lower values are drawn behind the higher values. Let's try this now. Right, and it's working. Perfect. So the drawing order was the issue, and now we can select the shield. This is great. So we have that. This should be disabled. So we can carry on. Okay, the same has to be done to set up the selling grid, which is pretty much the same, but different. So I can just really copy all of that and say selling grid container. Change this to say selling slot. Here we have items to sell, and here we will have on a selling slot. Let's create that function. It's going to be pretty much the same as the on buy slots clicked. So selling, here we do selected sell items index. Here we do selling grid container, and here we do sell button. Okay, so it should all work the same. So here I can select the sword or a shield. Perfect. Okay, so now there are some things that we need to perform when the sell button is pressed, and some stuff we need to perform when the buy button is pressed. So let's handle buy button pressed. So on buy button pressed. For I, in selected by item indexes, we need to do item to buy. The indentation is wrong. Is actually items to buy at I. We need access to a player, which we know we can get from a group. So get 3, get first node in a group, player as player. So first thing that we need to do is add the item that we would like to buy to the inventory of our player. So player, find child, inventory as inventory, add item, item to buy, item to buy stacks. Okay, because maybe we're, I don't know, buying like 30 arrows. And that should be item to buy. We need to calculate the goal to add to add to merchant inventory, which is item to buy price time item to buy stacks. We do gold with a reference to gold inventory item, which we don't have. So let's grab this gold. I believe this is just a gold coin, right? Yes. Then I can say gold coin scene stacks is equal to gold to add to merchant inventory. Need to get access to merchant. The simplest way to do it is actually to also add into a group. So I can go to shop scene, select the merchant, add a group, call this merchant, and go back to our shopping UI. Say, okay, merchant can be found in a tree as first node in a group merchant. Then I can say, we can cast him to merchant. Merchant. Items to buy. Erase. Item to buy. Merchant. Items to buy. Append. Gold coin scene. Buying grid container. We need to erase that child. And we need to erase that from buy indexes. Selected by item indexes. Erase I. And then we just set up buying grid and set up selling grid. So let's see whether we can actually buy this shield. Oh yes, that's not going to work. What we should do instead is just say gold item is equal to gold coin scene. Oh, well, it's not a scene actually, so we need to actually make it variable because it's not a scene, it's a research, right? Gold coin inventory item. Okay, let's just stop it. And now we should be good. So I'm going here, I am clicking on shield, I'm buying it, and it fails. Yeah, of course, it should be gold to add to merchant inventory. Let's try this again. And let's see. So I should have shield and I should not have gold. Let's see. Item to buy. This is on buy button press. I'm trying to have 90 gold. This is worth 90 gold. Let's buy this and I should have shield. Okay, you have some errors. Attempter is a variable of type array, of course, because that should be item to buy. Let's try this again. Buy and okay, he has gold, but our player doesn't have the shield. Let's see what is the item to buy here. Item to buy. It is a shield. Okay. Stepping forward and my player. Inventory. Items. It has a shield. Okay. It seems like it does not refresh correctly. So I know what the problem is. Problem is that we do not refresh the items to sell, because if I escape now and press M again, if I press tab, I can see the shield in my inventory and I can equip it, right? And if I go here, this is not getting refreshed. So we need to actually change our function when we set up the buying and selling grid to be a little bit different. So what we'll do in buying grid and selling grid, let's see, for the buying grid, we will do this. Get the player and we say, oh, sorry, this is gonna be selling grid. We get the player and we say, oh, it should be items to sell. That's one thing. Maybe that was the issue. Right. And now we buy. Okay. And yeah, now it works. That was the issue. One thing though, I wonder, buying grid container has 4 columns. I think they should be displayed horizontally. Oh yeah, that's what we were missing. So now I can go here, I can buy a shield, right? And then we also should remove the money from here. But let's handle selling first. So this is going to be pretty much the same, but a little bit different, as it always is. So on sell button press, do you have that connected? No. signal, and button pressed, and off we go. So we get the reference to merchant. And for I in selected sell item indexes, we do item to sell, we do selling grid container, get child at I, view free. We get the reference to a player. We can do it just once above. We say current items in player inventory is equal to player find child inventory as inventory items. Current items player inventory erase item to sell. Let's get some space here. And then we say you can also get access to inventory, because we'll be accessing it repeated amount of time. And here I can just say inventory. And then I can say inventory items is equal to current items in player inventory. Inventory, clear inventory slot at I, selected sell item indexes, clear, or sorry, erase I, merchant. We need to append this to items to buy. I can cast this to everything that I want. Merchant items to buy, append item to sell, and then gold to add to player is equal to item to sell price times item to sell stacks. Then I can say inventory, add item, gold coin inventory item, gold to add player. And that should be item instead of items. And then in the end, I do items to buy are equal to merchant items to buy. And we reset the grids. Okay, let's see how that works. So I try to sell a sword, and that gives me more gold, and the sword is moved here. Right, and in the end, I believe, yeah, we just select everything, so we need to also say sell button disabled is true, and then buy button disabled is true. Okay, so I can sell a sword that is worth 90 gold, and when I sell it I should have 90 gold, which is correct. And then if I buy a sword for 90 gold, the one thing that is not working is subtracting the gold from the player. So yeah, definitely, since this is long as hell already, I will leave it for you to implement remove gold from player inventory. Check whether player can buy item based on amount of his gold. Okay, I believe that's it. These are the things that you can add on your own, or maybe I will add them in next part. But I believe this tutorial, or should I say a course, was long enough. We implemented a lot when it comes to Zelda-like games. So we have basic setup for magic, fighting enemies, inventory, merchant, and scene transition along the tileset. I believe this set of features that we've implemented should be a good base for you to start working on your own game. So yeah, this course took a long time to prepare. I believe I will be shifting towards, well, smaller videos in the upcoming months. Uh, yeah, but thank you very much. I appreciate all of you, and I'll see you in the next one. Goodbye.